Okay, so you may remember yesterday, just as a review, I'm going to go back to the beginning for just a second, is that we started talking about step functions, about kind of this state machine that you can actually define using JSON that actually will walk basically through a workflow. And we talked about kind of the life cycle of going from like one task to the next inside of this state machine that can be visualized inside the console, and that there were a number of different types of tasks that you could have inside the state machine, including parallel tasks and things that wait, things that just like did pass through and surfaced like variables and whatnot, choice tasks, success and failure tasks. There were a couple of options, and that you could monitor the execution, and that a task actually could be a Lambda function, or it could be an external call of some type. And so we talked about like how this is a great way to orchestrate workflows using your Lambda functions so that you can actually orchestrate, entire kind of microservice sets, if you will. We covered a kind of a variety of different like terms about like a task itself, right? Whether it's a Lambda function or an external activity. The ID for the instance of the activity, the heartbeat that then checks to see if a particular task is still running, and then the failure states and success states, which tend to be kind of the endpoints, right, of whether a state machine like stops or not or terminates. Then we show just a simple pass-through task where basically it literally is just showing hello world as the result, where the input equals the output. So it's great for commentating or debugging. And then we started working through all the different state languages a little bit. And like this was a task that actually just invoked a Lambda function. It could also be a task that invokes an external call. And then we talked about the different like state types that could exist here. A task, choice, parallel, wait, fail, succeed, passing, which we saw at the very beginning. And then run a set of steps for each element in like an input array, right? And so here, again, another Lambda function. Then at the top actually is actually a hello world. So it looks like an external activity, like it's talking to some kind of like activity call. So it looks like it's calling something that's not a function, maybe something external, right? So this, by the way, an activity does consist, just to clear that up, of program code or a task that waits for an operator to perform an action or provide input, right? You can host these activities on, EC2 or ECS, so, or even on like a mobile device, by the way. So activities are going to pull the step functions using a certain set of API calls. And so activities, by the way, can represent workers, processes, threads, and they're implemented and hosted by you to perform a specific task. So this is an external code call. It's not a function call, right? And then we talked about the different types of control logic that are possible, including being parallelism and choice and just pass through, and then kind of like just waiting, like setting a pause, basically. Here was breakdown of the choice state, and then we talked about like the state differences of like a fail type versus a succeed type, including the fact that you could like throw errors or responses back, right? And then we talked briefly just about like the ways to trigger these step functions or state machines to start, which is either through the start execution through the step function API. You could actually have it be triggered through a Lambda, HTTP RESTful AJAX call, or you could have it be triggered based on an event or by time if you're using CloudWatch events, which is also now called EventBridge. And then the various APIs, which by the way follows just the standard of like listing and retrieving data and sending data, right? Updating an existing state machine, right? Obviously, you can create an activity, you can delete an activity, you can modify an activity, you can describe an activity, like all that, you can list all the activities in the system, you can stop an activity. So like all of the standard kind of CRUD applies for the most part for most of these API calls. You can actually create these state machines with that JSON using CloudFormation. And then you can, and as we saw before, you can continue to call with API Gateway. Obviously, once you get to a Lambda function, you can integrate with any other service that you want to. Everything like the API calls will get logged in CloudTrail. And if you have obviously specific outputs or executions for a Lambda function, they're actually going to show up in CloudWatch as well, which we saw yesterday because we saw that double stacking thing happening, right? So here's some like use cases where step functions might make sense. So here is some image processing. This is where you've got a Lambda function that is actually storing extracted metadata and object tags in DynamoDB. You've got other Lambda functions that are calling recognition, which actually does image analysis and recognition of the images inside of an image. You've also got Lambda functions that are generating image thumbnails, and you've got a function that's going to extract and validate image metadata. So like size, tags, anything else that's in there. So all these step functions can be orchestrated. That whole workflow can just be orchestrated using step functions. Now, that's just all image processing, right? So all the various steps in image processing are being handled by a Lambda function. The other thought here is that, here's one where basically you're running a step function state machine, and it looks like it's actually using a Lambda based on a schedule to trigger the step functions. And then I guess that's sending an email. And if the user responds to the email and clicks on it, it actually sends an API call to the API gateway, which then in turn sends an update to the step function. So it actually sends either task success or task failure based on, I guess, what the user clicks inside the email. So as an example. So another use case. Here, by the way, there is a task, looks like an activity that basically invokes manual approval. Obviously, if there's no response in 3,600 seconds, which would be an hour, that's going to be the end, right, of that particular task. All right, and that is step functions. So let's test our knowledge, because that was just really like a 30-minute module, honestly, on step functions. All right. So all work in your state machine is done by activities. Is that true or false? Was activities the way that we defined the steps in a step function, or were they called something else? Is that true or false? Yeah, so it's actually not done by activities. Tasks are the base like steps inside of a step function in the state machine. So that's actually false. And Bob, by the way, glad to hear that the map function supports parallel operations. I had that on my list to look up, so I will scratch that off. A pass state simply passes its input to its output, performing no work. Is that true or false? Did we say that the pass simply goes from input to output? Is that what it does? Is that true or false? It's true, actually. Yeah, 100%. Okay, good. State machines support branching, parallel runs, retry and error handling, and initiating tasks. Is that what state machines do? Do state machines support all of that? Yeah, I think they support branching, like going one direction or the other. They support parallelization. They definitely support retry and error handling. And of course, if they don't initiate tasks, then I'm not even sure why they're there. So yes, that is also true. Okay, I like this. So a choice state can only have two next tasks. Can they only have two options? Right? Two choices. Is that the only thing that they can support is two next tasks? Yeah, that's false. You can have as many choices, as you want to support. Okay. All right, so true or false, state machines are defined in JSON and you can visualize and monitor them in the console. Is that true? Can you visualize and define? Are they defined in JSON? Can you visualize them in the console? Yeah. All right, last but not least, can you start state machines? Can you kick off a step function via basically web calls intercepted by an API gateway? Can you do that? can API gateway basically kick off a state machine? Okay, that's true, actually. Good. All right. Thank you for participating this morning, shaking the rust off a little bit. Any questions about step functions, its role in conjunction with Lambda, why I would use them, anything there that you would want to talk about? No? Okay. All right. Let's talk about SQS and SNS, which are two sides of the same coin. So we're going to move past our serverless journey, which we had our lab, of course, yesterday. And we're going to move on to some of the more adjunctive services that are typically used in development in AWS to kind of create loose coupling, but also create scale, pub sub capability, a one-to-many kind of relationship between messaging. So there's tons of options here. All right. So we'll talk about SQS and SNS, and we will talk a little bit about Amazon MQ, which most people aren't aware of, but it's actually an open source standard where they're basically running active MQ inside of AWS. It doesn't have the same level of managed service and large scalability that SQS has, but it also complies with industry standards, so that can be worth it, right? All right, let's do it. All right, so why use a queuing service? Like, why are we now talking about queuing services like SQS and MQ? Like, who cares? Like, it's like, Michael, why are we talking about this? What does it matter, right? Well, consider a scenario where there's an application that's producing a message, right? And what needs to happen is that the producer is the one producing the message, and it needs to basically notify the consumer, right, that a message is available, and then it's waiting for the message to be processed. Then the consumer basically processes the message, right? And then it notifies the producer, hey, I ate the message, I processed it, right? And then a new message is generated. You notify the consumer, you process the message, right? And this kind of like whole thing happens, right? Now, here's the challenge. What if the consumer goes away? Like, if you're notifying the consumer directly, or like a set of consumers, what if it goes away? Like, if there's like a one-on-one relationship where you've got a web server and an app server, and you're like kicking things around, and there's no either load balancer or queue or something in there to basically handle failures on that layer, like with the application server versus the web server, how do you then create adaptability and redundancy? And this is where we insert in abstraction layers, right? Because let's say that while the message is processing, the consumer fails, still waiting for the message to be processed, right? That's assuming, by the way, that you've pinned, let's say you put 10 application servers into your web servers kind of like options list. That's if you've pinned the relationship between the web servers and the application servers, as an example. Is there a way to decouple that so that you can actually make it more scalable, and that way you can add and remove more or fewer app servers into the load, and then web servers don't need to know where the app servers are. They're just pointing towards either a load balancer or a queue, where the queue is actually holding the tickets of work, and then however many app servers you have can just go consume off those tickets, right? And so with an asynchronous process, what happens is the message goes into the queue, right? So does the next message, so does the next message, so does the next message. And then what happens is that any number of consumers, including the same consumer or another one, basically is just going to consume the message off the queue, process it, and then like delete it off the queue. And that is just going to repeat, right? And what this does is this gives a layer of decoupling or abstraction between the sending of the message, the holding of the message, and then of course the consumption of the message, which can be done by any number of consumers on the back end. This, by the way, whether it's a queue or a load balancer or any other abstraction layer, like even in a sense, like you could think about this as like this is what like virtualization does, right? It abstracts away the operating system into its own fake piece of hardware, which abstracts it away from the real hardware underneath. Containers do the same thing, right? You've got process isolation, and so you will take a little bit of an interruption, but you could actually move that workload over to another system. Same here. You could move this message be consumed by a different consumer, right? So, just to say this is that that's what we're looking for, is we're looking for the ability to create that abstraction layer. Let's see. One question I got is the transition between steps in a step function durable? I'm not really sure what you're asking there. Is it durable? Meaning what? If something fails on the back end, that's all handled at a high level. So step functions don't fail because of transition loss. They fail because the task that's being asked of them fails. What's the level of durability around that? Amazon doesn't share those details, right? But thus far, I've never seen a state machine fail because of one transition to the next, right? It just fails because the task itself doesn't work. So I don't know that Amazon has given enough technical details to know what they're doing there as far as durability. So I can't answer that, unfortunately. But I haven't seen one fail yet because of transition, only because the task that was asked to do was invalid or failed. All right, so then come in, if we're following this model of putting a queue in, this is where then we talk about the SQS service, right? So, and SQS, man, SQS is, so I know this is going to sound weird, but SQS was actually the first service launched, not S3. Everybody talks about S3 as if it was the first, service, but S3 wasn't actually. SQS was the first service. S3 was like a fast follower. And so even though I wasn't exclusively on cloud at that time, I very much remember when they first announced it, because they announced like that, and then they had SimpleDB and all this other stuff. Anyway, SQS has been around for quite some time. What's cool about that is that SQS for the longest time just had a standard queue, which did not guarantee order. It was not first in, first out. But it was super fast. It scaled incredibly well. And then they came out with a FIFO queue a few years back, and the FIFO queue actually was very different because even though it was limited to 3,000 messages per second, it did actually guarantee ordering was preserved. It made sure that you didn't have to mess around a whole lot with deduplication. And without batching, right, you could get 300 messages per second, but with batching, you could get 3,000 messages per second, which was really awesome, right? So FIFO queue started to add a little bit more of like the industry standard kind of consistency, like a toggle, if you will, to SQS queue types. So, so this is where, for example, if you look at this, this is where you've got EC2 instances that are talking to EC2 instances. Let's say it is our web servers and app servers, or maybe it's just an app's generic app server talking to like an ordering app server. And in this case, what happens is they're going to put a message in there. And what's going to happen is that the EC2 instances on the right-hand side are going to pull the queue. They're going to go talk to the queue and say, hey, do you have any work for me? And if they do have work for it, they're going to process the job. And then once they're done, they're going to delete the message off of the queue. So any unprocessed messages are going to remain in the queue, right? Until basically the system says, hey, I'm done. Now you might say to yourself, well, what happens if it goes to process the job, says I'm processing it, and then fails? What will happen is that the message goes into what's called a visibility timeout. And if the original machine that pulls the message doesn't come back and delete the message with a read receipt, by the way, you can't actually delete a message unless you've actually read it. It actually then, what happens is after a certain timeout, the message becomes visible again, right? So the message becomes visible again. And from there, what happens is that since the message is now visible, it's now can be picked up by another consumer if need be, right? To process the job. So here in the message lifecycle, you actually have a producer that is publishing a message to an SQS queue. And just to say this works actually kind of like similar to the way S3 and DynamoDB work, is that you've got these distributed servers on the back end that you never see, because this is a highly managed service. So you don't actually see the servers here, right? But what happens is that only a few of the servers, because they make at least three copies of your message, only 3 of the servers actually end up with the message. And what ends up happening is that depending on the type of polling that the consumer does, the consumer may not see the message, or it might see the message. If it does long polling, it's actually going to talk to every server on the back end and say, hey, by the way, do you have a ticket for me? If it does short polling, it actually might hit the systems because it's only going to hit a subset of the servers. And if it does short polling, it might actually hit servers that don't have the message on it because it's not talking to all the servers, right? So just as a general rule of thumb, most people tend to do long polling because it also reduces the cost, because you maintain a long persistent API call once instead of a dozen calls checking to see if the queue is available. Plus, it actually talks to all the backend systems and says, hey, does anybody have work for me? Anybody, right? Now, when you send a message, there's obviously the queue URL, which talks about the SQS queue you're using. There's the message body, and there's attributes in here. So note that you can also delay a message if you want to and say, hey, I don't want anybody to pick this message up for like 5 seconds or something like that, or 10 seconds or whatever. One thing to note here is the maximum message size. You may remember that a single row, right, or item inside of DynamoDB was limited to 400K. Just so you're aware, in SQS, the maximum message size by default is 256 kilobytes, so 256K. If you're using the SDK for Java, you can actually kind of meta message up to 2 gigabytes. So like you can actually put a large payload into using Java, but typically people don't do that. Typically, if something needs to be referred to like a larger data set, what will happen is that in that 256K message, they'll refer to an S3 URL or another data store, right? All right, so someone's produced a message. It's 256K in size. It's on servers, like you see over here on the right-hand side. And then what happens is that a consumer then will go to the queue and say, hey, do you have some work for me? And it says, yeah, actually, I've got message A from the queue. Here you go. This is yours, right? Go to 10. The consumer receives the message, right? And then, and whether it's short polling, which unfortunately, weirdly enough, is the default, long polling is actually better. What happens is that you can retrieve like the messages in question, and you'll actually get a read receipt, which I actually don't see listed here, which is a little weird, but you get a receipt ID basically. And you can't specify which message you're going to get, right? You're either going to get the next message if you're using a first in, first out queue, so you're going to get the next message available, or you're going to get a random set of messages. You can actually retrieve like a maximum of 10 messages at one time from a specified queue. It just depends on how you've orchestrated that. Remember that short polling is the default way to do it, which just checks a subset of all these servers. Long polling maintains a long persistent connection and says, hey, do you have work for me? Talk to everybody and then get back to me, right? Now, there are parameters when you receive a message. Sorry, just kicked my foot against the chair. Including one of the most important, which is the visibility timeout, right? So the visibility timeout says, hey, you've got 30 seconds to process this message before it becomes visible again. This, by the way, will allow you to put a timer inside your application that says, hey, by the way, after 30 seconds, you might want to go and change the message visibility on the queue by talking to it and saying, hey, can you change the message visibility by another 30 seconds? Because I need 30 more seconds to process. So just be aware that when you retrieve the message, it will tell you what its visibility timeout is, which is usually default for the entire queue, right? One question I received is SQS similar or comparable to Kafka? Kafka does a lot more than SQS does. So Kafka is more like a streaming bus, if you will. Like, I know that's mixing terms, but it's more like a streaming kind of data store. It's more for like streaming real-time kind of storage and analytics. whereas SQS is more like of kind of a trough. You just like stick messages in there and they get consumed, but it's not really built for real-time analytics, which is really what Kafka's really built for real-time streaming. Just so you know, there is a managed Kafka service on AWS. It's called MSK, right? So if you want Kafka and you don't want to run it yourself, there is an MSK managed Kafka service on AWS. And I had occasion to kick the tires on this recently because I have a buddy of mine who runs a company who was like, hey, can we go use this thing? Because they're tired of running Kafka servers. Because just to say this, Kafka is a huge pain in the rear end operationally, typically for most people. And they just don't want to be, they're not getting any differentiation by becoming experts in Kafka. So just to answer that question, they're not getting like, being good at Kafka is not core to their business, honestly. All right. So you receive the message. It tells you the visibility timeout. There's a couple other things that can be there, like, you know, wait time and whatnot. But basically, you get the message, you pull it down, you receive them, right? Now, once the consumer is done with the message, it has to go back to the queue within the visibility timeout period and delete it. If it does not delete it before the visibility timeout expires, then the message will become available and somebody else is going to pick it up, right? Now, by default, a message is retained for 4 days. Now you can change it for the queue to either be up to 14 days or as low as 60 seconds using like the set queue attribute action. But just know that when you retrieve the message, you actually do get a receipt handle. And so when you go to manipulate a message that's on the queue, you have to resubmit that receipt handle in order to pull that off, right? Think of the receipt handle as that because you've read this message, here's a handle that gives you permission to delete this message. So that when you go to like client.delete_message, you have to specify the queue URL and the receipt handle because that will allow you to delete that specific message, okay? All right. Oh, there it is. There's the parameters for URL and receipt handle, right? Notice the receipt handle is listed there as a large alphanumeric, right? So if you look down under HTTPS, if we look down below, right in this little section right here, you can see the receipt handle. Obviously, when you read the message, you get a receipt handle, so you want to hold on to that. You can, by the way, purge every message in the queue. If you want to call, like do a purge queue request, you can also obviously delete the queue, but don't do that. That's really catastrophic. Delete message batch, by the way, will allow you to delete up to 10 messages at a time, right? You can also read 10 messages at a time. So obviously your identifying URL is this kind of web-based URL. You can also use an ARN in some cases, right? But this like identifier right here can be found as in association with your queue when you create it. When creating a new, sorry, you basically will always want to use the queue URL when you're referencing the queue. For each message that you submit inside of a queue, it will actually assign a system like ID in the send message response. So when you send a message in, it actually is going to return a system assigned ID in case you need to identify a message, right? But like it allows you basically to identify messages that you've submitted. The maximum message length for like a message ID is actually like 100 characters. So and each time you receive a message from a queue, you get a receipt handle. So every time you go and receive it, I said this before, you get a receipt handle. That receipt handle is associated with the act of receiving a message, not like really with the message itself. So if you receive a message more than once, every time you receive it, you're going to get a different receipt handle. So if you read a message more than once, you're going to get a different receipt handle every single time. And again, just to restate this, if you go to delete a message, you have to provide the most recently received receipt handle to request the delete. Otherwise, the message might not be deleted. So keeping that in mind. Basic queue operations include things like creating a queue where you can set like the defaults, setting queue attributes, getting the queue URL if you need to retrieve it, listing all the queues in your account, or deleting a particular queue, right? All standard stuff, standard CRUD, actually. Here, by the way, is the differentiator between that short polling and long polling that I was talking about. So let's say you've got to, right, you're basically going to receive a message, right? And so what will happen is only a subset of the servers in short polling are actually asked, hey, do you have messages for me? So in this particular case, it might only talk to these 3 servers or 4 servers in gray. And so what ends up happening is that A, B, C, and D actually end up going, but like E, F, G, and like H aren't going to go because it's actually not talked to the other 4 servers. It only talked to a small smattering of them. Now with long polling, totally different. Long polling goes and says, go talk to every server. Let me know what messages are there. I can only pull 10 at a time, but I want you to talk to everybody, right? And what it will do is it will pull every message at that point in time. So just know that long polling is typically more efficient and preferred, even though short polling is the default. And the reason short polling is the default is that that's just where they started. And so they haven't changed it since, right? Now, let's say that you have producers who are producing messages into a queue and you've got consumers who are consuming messages and everything's working properly. The consumers are receiving messages, they're deleting them within the visibility timeout. But let's say that for some reason, there are messages that, like, for whatever reason, are just not being processed, right? So a dead letter queue is really just an Amazon queue that you define kind of off on the side to actually receive messages from other SQS queues in your account, right? And those by other queues are called source queues. And you set up a dead letter queue to receive messages that just could not be processed for whatever reason. So this allows you to isolate things that actually might be incredibly important, but for whatever reason are not processing. So you can actually have a consumer go out and occasionally check the dead letter queue and say, hey, what's going on? This message, and maybe when they check the dead letter queue, they handle it very differently, right? Right. What different, like in the sense of like, what difference does that make? Let's see. One question I got is that how does short polling and partial server list affect delivering messages in order? Just to say this, with a FIFO queue, it actually all the servers are like aware of like what the messages are. So like to go back to the FIFO description, right? Just know that with FIFO, message ordering is preserved. So even if you're using short polling with a FIFO queue, you are actually going to get the next message, even if it doesn't query all the servers, because all the servers are instantly told, hey, by the way, this is the next message in the system, right? So FIFO somewhat negates the negatives of short polling. But just to say this, the worst thing that's going to happen is you won't see a message, right? If that makes any sense, Bob. It's like the only message it's going to give you is in the next message. But if you talk to a server that hasn't seen the next message, you might get no message. So that's the worst thing that's going to happen. You're not going to get an out of order message. You're just not going to get a message, if that makes any sense. So message ordering is still guaranteed, even with short polling inside of a FIFO queue. But the problem is that you might not get a message in that request. But the next time you might come back and say, hey, do you have a message now? And that server could like have it, right? Because you're talking to a different set of servers. So it still makes sure that you only get the next message. But with short polling, there's a possibility that you're not going to get a message because that particular set of servers you talked to didn't have it, right? So what about reprocessing messages after they have been deleted from the queue? Well, I mean, if the message has been deleted, there's not going to be any reprocessing because the message is gone. So you might have to clarify that use case for me if a little bit deeper.
Yeah, because it's all async. So what if the client has introduced an enhancement, quote unquote, right? And
right.
Turns out that enhancement has, it's working, but it's not working the way they thought it was going to work, and they need those messages that have already been deleted. So they're looking to go back in time and reprocess those in some way.
They have to be resubmitted. You can't recover like deleted messages off of a queue. They're gone at that point. You have to get the producer to resubmit the jobs, basically. So let's say that you identify that images 1000 through 2000 were the problem because of like a change or of some type, and you want to resubmit those images for processing because you've now like fixed or changed, added an enhancement or feature. You would just get the producer to resubmit those images as jobs. Unfortunately, at least to my knowledge, I've never seen it. You can't recover messages once they're gone. They're deleted. I have seen some clients maintain a database of all processed jobs that come through the queue, so that at least that way they can do some reconciliation, and they'll keep a track of everything they've submitted and everything they've processed in the same like data store, so they can actually see the status of the job. I have seen some people do that, like they'll use like a DynamoDB database. But once the job is deleted, it's gone. If you need that level of recoverability, then you would probably look at something like an ActiveMQ, or which is one of the managed services, or you could use Kafka or something like that for that. So unfortunately, SQS doesn't do that. All right. Oh, is worth mentioning that dead letter queues, if you decide to have a queue that's a catch-all, which is basically what a dead letter queue is, they do have to reside in the same region as your standard queues. So it says it can do it for a bunch of different queues, but just so you know, it's all the queues in a region can have a dead letter queue, right? And queues in another region can have a dead letter queue. I will tell you, I don't typically mix dead letter queues. Typically, I keep a dead letter queue for a queue, not for all queues, because that gets weird. Because then I got to have a bunch of application logic there to handle that. Because SQS predates IAM, just like S3 and SNS, it does have resource-based permissions. And what's cool, just like S3 and SNS, is that you could actually like let people publicly access your SQS queue. You can even charge them for the use of their queue if they're using an AWS account, right? But typically the queue owner pays for all access to the account. So be very mindful if you share a queue with somebody. If they go crazy, then you're gonna be left with a bill, right? You can encrypt, obviously, relatively new feature, right? This actually just uses the KMS service, which is the key management service in AWS. So this would then just recall, it would get like a data encryption key basically off of the customer master key, and would basically encrypt messages as they came in. Just so you know, if you do this, one of the permissions that need to be added to the consumer role on whatever, Lambda or whatever that you're using, you need to make sure it has KMS decrypt. Why? Because if the message is encrypted with KMS, make sure that you've got decrypt permissions on your consumers. So the producers have to have encrypt permissions. Sorry, the producer actually has to have decrypt and generate data key permissions, and the consumers have to have decrypt permissions. So just something to be aware of is that you do actually need to add a different set of permissions if you decide to encrypt your queue. It will tell you, by the way, you don't have permissions to encrypt or decrypt these messages. Then you need to add some permissions. I don't even know. Like if you need a queue, this is a great option. If you need a queue and you don't need industry standards and you want that level of performance, right, then this is a great option. So the simple queuing service works spectacularly for this. If you need a queue and you need AM, oh my God, my brain just stopped working. AMQ, TT, oh my God, I just literally forgot all the standards for queuing, but we'll get to them when we get to Amazon MQ. If you need industry standards for accessing a queue, then you're not going to use SQS. You're going to use ActiveMQ, right, or Amazon MQ. Now, you can combine SQS as an example with SNS, so you can get a fan out model pretty quickly and easily. But as far as like, auto scaling, buffer and batch operations, any kind of async insertion, SQS is great. Now, one thing that's actually pretty cool, which you might find interesting, is that if you attach a fleet of like an auto scaling group of EC2 instances to a queue, you can actually trigger your EC2 instances to expand and contract based on the number of jobs that are in the queue, which is great, right? I mean, that's really a great option. So, you know, in that particular way, like as the queue grows, you can actually grow your backend consumers, right? Which is awesome. So just know that the queue will link with an auto scaling group, so you can expand and contract your EC2 virtual machines and or your containers if you want to as well. With Lambda, by the way, Lambda is going to go to whatever max concurrent execution level you set. So every time a message hits, it's going to trigger Lambda. So make sure that, you know, you've got capacity there. Let's see. Let's see. Question I got is anticipating the recovered deleted messages scenario. Can I save a copy of the message somewhere before deleting? You were unsure if the question makes sense. So that was the scenario I was talking about earlier, is that I have been in environments where people save the message before submitting it. So they have a copy of the message like in a database, and then as the consumer eats it off the queue, they'll update the processing state in like a DynamoDB database, as in this particular case, to say they process it. And if it needs to be reprocessed, they just go back to the database and have the producer resubmit the jobs from the database. So hope that answers that question. Is that you can either do it before you submit it or after you submit it, but you can't actually, you know, save it. And, you know, I think, let's say in 2014, I think those guys were actually writing it to a file. I think they were writing the jobs to like an S3 bucket, actually saying, here you go. So they weren't even sticking that in the database. Yeah. But database is preferred. It's a lot easier to manage. So overall, just know that this is what the SQS service does: is it's an asynchronous, you know, queue. And notice here, by the way, that the way they've got this one set up is that they've actually got a web server that's submitting like requests, and the responses are coming in to the SQS queue, which are then being picked up by the web servers. I have to say, haven't really seen that. Kind of weird, but it's fair enough, right? Usually what the response queue actually ends up being is an SNS call, where basically the consumers basically just trigger a response message directly back to the consumer instead of talking through a web server. But it just depends on your use case. Okay, so that was SQS. Here's a quick question for you. What is the maximum message size that you can submit by default, not using any special SDKs, with SQS? What's the default? Yeah, 256 kilobytes. Make sure that's clear. Good. What is the default for polling? Is it short polling or long polling? Yeah, short is the default. What's the maximum number of days that you can retain a message on an SQS queue? Like if you change it, right? Not the default, but what's the maximum that you can retain a message? Good. Good. What's the default number of days if you don't actually change the retention period? What's the default number of days out of the box when you create an SQS queue that it will retain? Good. Good. 4 days. Excellent. All right. There's other questions, but we're going to keep moving forward. Okay. Let's talk about SNS, and then we'll probably take a short break. Okay. So if SQS is a you go and ask for work model, SNS is a pub sub model, which means you subscribe and work is pushed to you. Right? So the simple notification service has subscribers who go and say, yes, I am willing to receive messages from you. And when a message is published by a publisher, it then hits the topic, which is the unit of presentation, really, inside of SNS. And then it hits all of these subscribed entities in a subscriber base for that topic, right? By the way, this could be a Lambda function. This could be another SQS queue, right? Not just SNS. It could be an HTTP or HTTPS post. You could send an email, right? You could send an SMS notification. You could do a mobile push if you wanted to. There are options. Now, here's a fan out option where what's happening is that this someone like publishes a new stock price, and this could hit multiple queues that might have different kind of like processing options in response to this price, like a calculation engine or a trade reporting system. And what ends up happening is that these queues are actually watched by different sets of EC2 virtual machines, which have very different functions, right? So here, SNS encodes a message to Amazon SQS. So SNS goes to SQS, and what it's doing is it is encoding the message in a JSON format when it sends it to SQS, as well as any metadata about the message, right? If you decide you're going to enable raw delivery because you don't want it to do JSON encoding, what will happen is it just sends the message as is with no like encoding or no metadata, right? So here, the original producer sent a JSON formatted message to SNS. SNS then simply publishes the message as is without adding any SNS metadata, right? So you get to control whether it's JSON or just straight up raw as far as the message submission to SQS. So here with raw message delivery, it's just delivered as is. No messing around. Okay, so let's go back to some image processing scenario here. We got a user, they drop a file inside an S3 bucket. This triggers a response to an SNS topic, which immediately is like, boom, let's actually make a thumbnail, a mobile size version of the message, and let's size this for desktop/web. And then we're going to hit this queue. And when the message hits the queue, it's going to trigger a Lambda function, which is going to do some processing, maybe even like, do some encoding of some type. And then when it's done, it's going to publish this into an S3 bucket. Notice there isn't a single server here. Code sits in Lambda. Execution is all triggered with managed services. And then you can put CloudFront in front of the destination bucket and go from there, right? All right, what can you do? What kind of operations can you do to an SNS topic? Well, just like a queue, you can create a queue. One of the things that you can't do with a queue is, obviously you can poll a queue in SQS. Here, you're going to subscribe to a particular topic, right? And by the way, this is like consent. You're like, yes, I am willing to receive messages from you, right? You can also delete a topic if you want to, which obviously is fairly catastrophic. And the other thing you can is you can publish a message. So as a consumer, you might subscribe. As a publisher, you'll publish, right? Those are really the two things, right? Now, just to say this, by default, you can only create 3,000 topics inside of a single account. If that's a lot. Let's just say this, that's a lot of topics, right? Trying to think of something else. You can confirm a subscription, much like like we do with consent and authorization. You can say, hey, yes, I actually do consent to receiving topics. I don't know if there's anything else to share that's useful there. Here we got an online buyer who is hitting an e-commerce website, right? And what's happening is that has these kind of orders are canceled or orders are placed or a product page is visited. This is hitting a shopping events topic, and different messages, by the way, can be routed to different things. So like by default, a subscriber of an Amazon SNS topic is going to receive every message. To receive only a subset of the messages, a subscriber, meaning the person who has like said, I will receive message to you, can actually assign a filter policy to their subscription to the topic, right? So this can simplify pub sub messaging by saying, look, I only want to receive where event type equals ordered canceled or ordered placed. And notice that those are the pink messages and they are going up to the payment gateway, right? And the Lambda function, when it's subscribed actually, you can say, look, I only want to receive things where the product page is visited because I want to match that against the search engine, right? This can, by the way, be numeric and string matching. Now, in this case, it would be string matching, right? So you can be exact, you can look for a prefix, or you can say anything but this, right? Comparisons. While numeric matching allows for exact and range comparisons greater than and less than, right? So just know you can do string matching and numeric matching for your filtering policy. So just know. All right, so notice here, they've created a topic, shopping events, and they have subscribed to that topic RN, in this case would be shopping events, and they're subscribing the endpoint, in this case, the search index function, right? And then they're setting the subscription attributes, and they're saying, look, here's my filter policy, and I only want to receive events where the event type is product page visited. So if we go back, see where that blue box where it says event type equals product page visited, that's what they're doing down here at the bottom, is they're saying, I only want to subscribe and receive messages where event type equals product page visited. Here, the message attribute event type is actually like more like defined when they're publishing the message. So here was the subscriber, and then here was the message with message attribute saying event underscore type, and the string value equals the product page visited. So this would match the filter policy and therefore hit that Lambda function, right? So filter policies, by the way, are a relatively recent addition to SNS topics, but they're super powerful because instead of having to have multiple queues that you fan out, you can now make it conditional inside the queue which messages go to which subscribers, which is really nice, actually. Couple things about SNS, right? Same data limitation, 256 kilobytes of data, right? Do note that it in some cases it will actually like retry. You can control some of that, right? But just to say this, you cannot recall or delete a message once it's been published, right? And there's no guaranteed delivery, especially with like email as an example, right? But you get detailed control over endpoint access over email, right? You can like control who it gets access to published messages based on IAM policies, and you can actually grant access to who can subscribe through IAM policies as well. Now, SQS and SNS operate slightly differently, so we're just going to do a little comparison. So SQS is very persistent with messages, right? And I don't know that I've ever lost a message on SQS. It's kind of like step functions. I've never had a state machine fail on me for any reason other than tasks, right? SNS does not persist messages. Once it hits the topic, it flows through, it goes out, and you might be able to catch the message if it's in a retry state, but for the most part, you're not going to see it. It just goes out, right? With SQS, you go to the queue and you pull it, right? So that's an active on the client side. With SNS, you just receive the message. The client didn't have to do anything. They've already subscribed. That was their only activity. And when a message is sent, it just comes straight to the client or subscriber, right? The SQS is typically a one-to-one relationship between published message and consumption of the message, whereas SNS is completely like a multiplier. It's a one-to-many relationship, right? From publishing to messaging. And then SQS is pretty like async, whereas SNS, if it publishes a message and there's no retry option for the medium that it's using, you won't get the message, right? It'll be dropped. You'll miss it. All right. Questions thus far. Sorry. Okay. Let's talk about then MQ. This is going to be a short conversation because MQ is actually pretty straightforward. MQ is like the like industry standards version of SQS, right? It's much younger. I think it's only been out for like the last year or so, 2 years, maybe 3. And it's a message broker service, and it's basically designed so that you can actually basically run Apache's ActiveMQ, right? I hope I said ActiveMQ earlier. I hope I didn't say RabbitMQ. It's ActiveMQ, right? It is easy to set up and operate message brokers in the cloud. It is kind of node based, so this isn't really this is more like a platform service than it is like a SaaS service. You get direct access to the Apache MQ console, which allows you to do all kinds of things. This is the one, and this is the thing I couldn't remember earlier, is that it supports all the standard stuff around JMS, NMS, AMQP, Stomp, MQTT. They were all jumbled in my brain for whatever reason. All the standard kind of like messaging protocols, right? This, by the way, will allow you to lift and shift stuff to the cloud without having to rewrite things for SQS if you're already using a system like this. So instead of rolling your own EC2 instance of ActiveMQ, you could actually just use this service. Now, from a durability standpoint, it will actually support an active standby broker for high availability. You'll end up with 2 brokers, 2 kind of nodes, and 2 different availability zones. They will be a redundant pair. They will communicate synchronously. They will use EFS on the back end, right, with a shared storage location. And by default, it uses the Elastic file system. So to take advantage of this, right, of the low latency, high throughput, if you need to improve that, you can actually change that to the Elastic Block Store if you want to. I will tell you, I know this sounds weird, but EBS now supports multi-attach. You can actually attach a block volume, a disk, to multiple systems. You really don't want to do that unless you have a cluster file system on there. So EFS is still the preferred mechanism for sharing the data between systems. Just know that EFS will go across an entire region. If you decide to replace that with an EBS volume, which is just basically a virtual hard drive, it will only work in a single availability zone. So I'm really kind of curious how that would actually function here. I've actually not run this at all, so I have some questions. So this can be created as a single instance broker or active standby broker. It just depends. Regardless, just to say this, the storage is highly durable across multiple AZs. So, you don't have to worry about losing your data. You might lose the node for a second until it comes back up if you're running single instance. In the event of a failure, it does do automatic failover over to the second node and changes the broker like DNS name, the reference. So just know that this is available to kick the tires on, constantly evolving. Here, by the way, there's a hybrid integration model where basically if you're lifting and shifting and you just want to replicate messages out, you can actually hook MQ on-premise up to your MQ in the cloud and replicate messages to a cloud-based consumer versus an on-premises consumer. And it can be obviously sourced from an on-premises producer in this case. Kind of a little thing about SQS and SNS versus MQ. So, they say that MQ is actually for application migration. I actually think it's for anything where you actually need to use industry standards. You can see over here is that the protocols supported are much broader and different than what's on the right-hand side. Amazon MQ has a bunch more industry standard features as well. It will cost you a little bit more because you're going to pay on multiple dimensions, which is basically the node per hour and the per gigabyte storage that you're using. And of course, it supports all the standard kind of like pub sub kind of industry standard queuing models. Whereas, the only thing that supports pub sub on the right side is actually SNS. SQS supports the poll model only. Okay, let's do a little knowledge check. First of all, are there any questions of any type about SNS, SQS, or Amazon MQ?
For SNS, I got a little confused in there. So when you publish a message, obviously, like you said, there's subscribers. So does that message stay out there? Is it just the subscribers that get it? Just a little confused on the in-between mode.
Yeah. So what happens is that it depends on the medium that we're talking about, right? So for example, If it's SMS, it just gets sent out. And if the number is either not available or not receiving messages or whatever, obviously that depends on the queuing system on the cellular side, right? If it's a mobile push, you can actually control some retries. If it's email, what if that email gets lost? So all it does is send the email, and once it's sent, it's gone, right? From their perspective, they're like, I've sent an email, I've sent the message. They're not tracking the message because you can't track the messages through other systems. Amazon doesn't have the ability to track the messages through other systems, right? HTTP posts, which is that fourth block from the top, you can't actually control retries on that. And SQS, I think you can also control retries. Lambda just gets triggered, right? And so then it's actually running through the Lambda system, but you're not going to get responses because there's nothing here to respond to. Like nothing's going to respond and say, hey, by the way, I sent this email and I got a kickback saying the email doesn't exist. I mean, how did that subscriber even end up on the topic to begin with, right? So once the message is sent, it's kind of gone unless it's in a retry state because it's now in other systems that SNS is not tracking. Does that make sense?
Yeah, so the SNS just doesn't like stay there. Like I keep thinking like it's, I'll use queue just because it's a familiar, terminology. Like it just doesn't stay there and the subscribers go and check it and run through a list or anything like that. Like it just pushes out and it's
Yeah.
done. Okay.
Yeah.
That's
like
where my confusion was coming. It's like, how do they ever get rid of it? How do you know that you process that one? A whole bunch of different things. So
yeah, it's very async. It like throws the message out there. It doesn't even know if it's someone caught it, right? Now, there's an assumption that when you subscribe to a topic that you are subscribing, right? Because you get a message, like for example, if you subscribe to your email, you get an email saying, by the way, did you want me to subscribe to this? Please confirm, right? So it assumes that when you subscribe to it, that's enough validation for you to actually receive a message. But that doesn't always guarantee that you're going to get the message, right? So there's no guaranteed like delivery with SNS because of these other systems that are involved. But it does not hold on to the message in any way, shape, or form. It sends it, lets it go. That's it. Done. Been given to other systems. I'm out. Now, don't get me wrong. It'll iterate through every subscriber it has, right? So it's not like it's going to abandon a subscriber. But if the subscriber's system isn't ready to receive it or like whatever reason doesn't get it, SNS doesn't really care. So if you want to guarantee delivery, you're probably going to look at a queue, honestly. And that was Dawn, right?
yes.
Okay, just checking. Good. Other questions?
Oh, so when you say that it can do the filter, that filter attribute you can define yourself, right? Not like a predefined attribute. Async is a filter.
Oh, the filter policy. Yes, the filter policy is controlled by you.
Okay.
Yeah. So when you subscribe, you get to say the types of messages you want to filter against. So when you as the consumer subscribe to a topic that's being published by somebody else, you can say, hey, I only want messages where string equals this, or the number equals this, or the number range equals this.
Right, like this kind of attribute, like just for example, okay, so example, so we have like we need to send out when we have email and we something processed, then we need to send the email. And based on different field office, we like this message is just for that field office, another one for another field office. So we can like define something in the message, and then field can grab that thing in the filter.
Yes, but just to say this is that whoever is in that field office, if they were subscribing, they would have to apply a message a filter that basically says, I only want messages if they're for like Dallas, for example, has a field
Okay.
office, right? So the subscriber would have to like submit that as a policy. And then when you publish the message, you'd have to set that field and say field office equals Dallas, and then they would get Dallas, would get it, right?
Okay, thanks. Yeah.
Yeah. So it requires, subscription modification on the consumer side and publication modification on the publisher side. So both have to be in alignment. Okay. Good questions, by the way. Upper left-hand side, SQS gives you access to a message queue that can be used to store messages while waiting for a consumer to process them. Is that true or false? Does SQS give you a messaging queue? Is that true? Allows you to store messages while waiting for a consumer to process them? Is that what SQS does? Is that what the simple queuing service does? Does it actually give you a queue? Yeah, the answer to that is yes. Right? Now, here's an interesting question. With a standard SQS queue, is messaging order guaranteed? Is that true or false? Yeah. FIFO queue, yes. Standard queue, no, that's not true. All right. Oh, dang it. I went ahead a little bit. Now you know that's false. All right. So now you know you can't filter messages when subscribing to an SNS topic. You always receive all messages published. So that's not true. We just had a conversation on that. So you know that's false. Right. All right. So when Amazon SNS sends a message to Amazon SQS, it encodes the message as a document. Is that true or false? By default. Yeah. So by default, it is going to encode it as a JSON document. If you want to change that, you just set up raw delivery. That's it. Okay, last but not least, Amazon MQ supports JMS, NMS, AMQP, STOMP, and MQTT. Does it support, and WebSocket protocols? Does it support all those protocols? The ones that I couldn't repeat earlier? Does it support all those? Yeah. It's an industry standard tool, so it supports all the standard protocols for messaging, right? That is accurate. Okay. So here's what we're going to do now is we're going to take a short break. All right. So we're going to take a short break. When you come back in 15 minutes, well, I'll tell you what we do then. So right now, let's say it's 9:50. Let's come back at 10:05. I'll put a timer up. When you come back at 10:05, we're going to roll into our next phase. Okay. So everyone go take a break. We'll see you in a bit. All right. All right, so we're going to developing messaging solutions with SQS and SNS. So here's what's going to happen is that you're going to basically, you're going to learn how to use the SDK to just receive and send messages against the SNS and SQS services. You're going to learn how to set it up, implement a fan out scenario. And so you're going to set up some topics, some queues, develop an SNS publisher and an SQS consumer, right? That's like pretty straightforward what's going to happen. Now the lab itself, that's weird that it would just like drop labs. Weird. Anyway, the lab itself basically starts just like every other lab that we've done, right? And what's going to happen is that, once again, you have solutions code in this case, but you're going to open up the console and you're going to set the following topics and queues required for your notification, right? So you're going to do this kind of one at a time. So an SNS topic for email, an SNS topic for order, and then 2 SQS queues, A and B in this particular case. So you're going to create like subscriptions and all these other pieces. Now, just something to be mindful of is that, again, if you're waiting on the console to present updated information to you, do note that even though you have a refresh button, you just want to refresh it on a consistent basis. And also know that it does take a while for messages to kind of get through an email system, especially a corporate email system. So bottom line, you might need to be patient. I know. I hate it too, right? Now, the other thing is that once you create the queues and you create the SNS topics and you subscribe to them, this is all being done in the console in this particular case, is that you're going to develop a publisher, right? And so, yeah, I don't know. There's really much to say about that. Obviously, you have solution code, which is there and working already, and a number of like different methods that are present. And then once you get all that working, you're actually going to check and see, once you actually run the code, you're going to see that you received a message against your email SNS topic. Just know, especially if you use a corporate email to subscribe, it can take a while for it to get through. And then you're going to navigate through the console and take a look at the 10 messages that are available in the queue. You can also see polling progress, right, as you kind of like look through a particular queue. And then you're going to develop an SQS consumer, right? So at this point, you've published messages to SNS, which in turn has connected to an SQS queue. And then you're going to develop your SQS consumer, which is actually going to consume off of the queue in question. So And then there's a couple of tests there, and then that's pretty much it. Like it's just really that straightforward. And so we're doing lab 5. I don't remember. Hold on 1 second. I think this is a 45-minute lab typically, but let's just say 45 minutes. And so what's going to happen is it's 10:10 right now. So I'm going to check back in like pretty close to the 11 o'clock hour, and we'll see. When you're done, per the usual, please make sure that you either check a green box or just tell me that you're done, and that way I can like track where everyone's progress. Okay, so that's it. We're gonna do lab 5. Go ahead and hop on in. Oh, it does say 45 minutes right there. Good. The labs were pre-warmed. There seemed to be a little bit of hiccup, so that you might have to wait a minute or two, but it should be good. It's been pre-warming now for about 15 or 20 minutes, so there shouldn't be any issue here as far as like the labs being up and running. But if they do say provisioning, just give them a minute or two longer. It shouldn't be much longer, but I think they're like ready to go. Okay. All right, let's go forth and conquer. I will give you guys space. We'll go from there. Okay. So this is literally just going to be the lightest skim I've ever seen on Elasticache. It's like, heck, like in the official schedule, it's like we got 20 minutes on this. But just to say this, there isn't much depth in Elasticache, at least from like a describing what it is kind of scenario. Elasticache is basically, the core service that's used for caching, but people also use DynamoDB for this as well. So it's not the only one. But the benefits of caching, whether it's at a global network level or at an application to database or web caching, there's all kinds of caching, obviously. The idea here is that especially if it's data that has a certain level of staleness to it, it actually improves application speed, because then you don't have to go back to the database to get data, or you don't have to go back to the source to get data. You don't have to go back to the web to get data. You're not pulling back images. I mean, we do this client side in the browser all the time. And because you don't have to go back and do some kind of compute function, usually it reduces latency. It can actually definitely reduce the load on database queries and can provide performance gains just because of all the aforementioned options. Now, you want to consider caching with any data that's expensive and slow to compute, that especially once you compute it is actually not stale for at least a second or two. Even that's worth it, especially if there's a lot of queries against that for that same data set. If the data is relatively static and frequently accessed, those are ideal. That's ideal data, right, for caching. And of course, information that can afford to be stale for some time, seconds, hours, days, that's great data for caching, especially if it costs you something to derive it. Now, Elasticache is the primary service designed for this function. So just know that, when you have load balancers in flight and you've got application servers, and those app servers are talking to a backend database, they could actually hit a cache either first or second, depending on what your caching strategy is. Especially, by the way, if you're hitting to uncontrolled third parties and you can afford for the data to be stale, that's a great option for caching as well. So Elasticache is a AWS service which makes it easy to deploy, operate, and scale, basically an in-memory cache in the cloud. Now it comes in 2 flavors, Memcached and Redis, right? Those are the 2 flavors that you can actually get for this. So Memcached and Redis are the 2 open source analogs that you can get copies for. These are the database technologies that underpin these in-memory caches. Now, just to say this, there's a bunch of stuff here about like, do you choose Redis over Memcache, blah, 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 blah. Let me just break this down for you really easily. If you just want a very simple cache that doesn't do any sorting, ranking, pub sub, or anything like that, and you don't necessarily need multi-AZ kind of support, then you're going to use Memcached. I got to tell you, very few people that I know actually have those requirements, because in order to use AWS correctly, they typically recommend that you're multi-AZ, right? At least 2 availability zones in a region. So almost everybody I know uses Elasticache for Redis. Doesn't mean that people haven't used Memcache, but in production, Elasticache for Redis seems to be where everybody goes, right? Just to say this, with version 3.2 of Redis, which I think they're on, 3.4, 3.5. I honestly don't remember the exact number. This this is a in-memory cache that can go to 3.5 terabytes of in-memory data cache, which is like super fast. You can be atomic with it. You can do pub sub. You can do sorting and ranking. You can have read replicas. You can have writers versus read replicas. You can do cluster mode or standalone or sharded clusters. Redis has so many ridiculous features inside of Elasticache, right? That it's ridiculous. Memcache, by comparison, is great in its simplicity, but it doesn't really have the HA capabilities nor the advanced like sorting, ranking, pub sub stuff that Redis has, right? So, you know, and it does also support partitioning your data across like 1 to 15 shards. These are called node groups inside of Redis, by the way. You know, so just know, and you can obviously enable a cluster mode if you need to get to larger clusters, or if you need complex data types. Any of those criteria, it's going to be Redis. So let me just say this is if you're going to do it, you don't really know, just go ahead and choose Redis, right? Unless you're just like, I'm just out here messing around, so just use memcached. So, but like Redis also supports things like strings, hashes, lists, sets, bitmaps, weird things like hypolog logs. I don't even know how to say that word properly. Geospatial indexes with radius queries, sorted sets with like range queries as well. Sorry, that was my memory me slapping the desk, right? So just know Redis is over and above feature rich compared to memcached. So yeah, so Bob, memcache like doesn't really out of the box, like from a cluster perspective, support multiple AZs. You can run single node clusters of memcache, but in terms of like a replication set, out of the box, memcache doesn't support multi-availability zones, which doesn't mean you couldn't have multiple memcache single node clusters around, but you wouldn't necessarily get replication. And that may not be necessary. So like, who cares? So you can figure that multi-availability zone support out, but you have to figure it out in the application code. It doesn't do it for you. So. All right. Here's another little comparison chart. Notice that, well, it actually just repeats most of what I just said, actually. The multi-threaded performance thing, by the way, shows up on exams, which I don't really understand because it is true that memcache can multi-thread and Redis is not that great on it. But that, you know, that's not going to stop most people from needing the sorting, ranking data sets or persistence or any of the other stuff that Redis offers. So, yeah. So the various Elasticache terminology. So just know like a node is the smallest building block of an Elasticache deployment. And a node is like a like fixed size chunk of a secure network attached piece of RAM. Like think of it as like a server almost, right? And each node is either running an instance of memcache or it's running an instance of Redis, depending on which was selected. Now a cluster is a logical grouping of one of more of these little cache nodes, right? So, and then you can have what they call also replication groups, which is a collection of Redis clusters. And there's usually like one primary read-write cluster and up to 5 secondary read-only clusters, which are just called read replicas, just like any other technology. Now, each read replica maintains a copy of the data from the primary cluster. And just to say this, it is asynchronous. So it's, you know, there can be lag. It's like eventual consistency, right? Applications can read from any cluster in the particular like replication group, but applications can only write to the primary read-write cluster. So that replica does enhance the scalability. It guards against data loss, right? And so you do get a reader endpoint and a writer endpoint. The writer endpoint obviously goes to the primary cluster. The reader endpoints go to, you know, whatever read replicas you have, right? Question was, does Redis support encrypted replication? If the data type's encrypted in memory, it's encrypted in, right? It's encrypted in replication as well. Let's see. Is there anything else to say here? Oh, yeah. So once you've got nodes inside of a cluster and you've got your cluster, your replication group set up, and you've got all that figured out, one thing to note is that, you know, does every write like load the write up into cache, or does it load it back into the like obviously it loads it back to the database because you want like the persistent data storage, right? But like whatever your strategy is, how do you manage the cache to make sure it has the relevant data but not data that isn't necessarily going to be used? do you write everything that you write to the database into cache, or do you go to cache first, and when you miss the cache, do you then go write it to the database? But then you, like, it depends on whether you're doing reads or writes, right? It like just depends on like what you want to do there. For reads, what you typically want is you want to hit the cache. But how do you write data so that the correct data is actually in the cache, so that when you go to read it, it's there, it's fresh, it's not stale, it hasn't like violated the time to live, because you can actually set TTLs on this data set and say, look, if this thing's older than 5 seconds, it's out. Drop it, it's stale, force the application to go back to the database, right? So there's all these questions about how you manage cache in when you like roll a cache in, and it doesn't matter whether it's Elasticache or Dynamo or whatever caching mechanism. How do you do that, right? And so this is where we talk about like just different types of caching strategies that are generally like looked at. There are tons other ways to approach this, but one of the most common is lazy loading, where you actually go to the cache first in your application and say, hey, do you have the data I'm looking for? If you hit the cache, great. Take it back to the client, you're done. If you go to the cache and you miss the cache because the data isn't there, well, then what would happen is that you would then go read it from the database, and then the application would then write it up to the cache. Now, the cool thing about this is that the only data that's going to be in that Elasticache cluster is data that was missed by the client, which, by the way, assumes that more than one client actually wants it. So like, just to throw that out there. The problem is that now if you miss the cache, you now have a penalty where you have to go grab it from the database, maybe return it to the client, and then you're going to write it out to the cache, right? And the application may get data that's relevant for that particular request, but maybe it's not relevant for the next 6 requests, right? And this is okay because node failure isn't fatal. So for example, if you lose a node inside Elasticache that's not replicated, then it's not that big of a deal, because if the data is missed, it's just going to grab it from the database and repopulate, right? One request at a time. But there is a cache miss penalty. You go to cache, you miss, you go to the database, you miss, and you pull it from the database, and then you have to write it to cache. So you have to take 3 trips if you miss cache in this particular case. But it's very precise. So it's lean. It's a lean way to populate your cache, right? Now, compare that with write through, which basically says, look, every single write this application does back to the database, whether it's a creation, an update, right? Or even to the delete, I want you to do those same CRUD operations, exception to read, against the Elasticache system. Now that's awesome, because you can always make sure that the latest data is inside your Elasticache. But just to say this, now you've got a much larger data set, and some of that data may never be used. It just because every write is getting copied in the database doesn't mean you need to cache every write. What if that's just a one-time write or a one-time update? Like, how does that work exactly? But the cool thing about this is that, you get the latest data, but there is a write penalty, because now you're writing to 2 places every time you write, right? And if a new node starts, it won't have the data set. Now, if a new node starts and it's in a replicated cluster, then of course it's going to have the data set, right? But if you do like a new standalone node, you're going to have to like figure out how to update that with a copy of the data that's already in another Elasticache cluster, which, by the way, is relatively trivial to solve, but it is a problem, right? There is a lot of data that won't be read, so you can actually be dealing with unused data. And just to say this, the cache is going to be updated every time the database is updated. What if the cache doesn't need that? That's called cache churn. And so if certain records are updated repeatedly, but they're not read repeatedly, this could be inefficient, right? But it does guarantee that the data is never stale. So if staleness is your primary thing that you must absolutely avoid, then write through is awesome. If you need leanness, then you want to use lazy loading, right? And those are the general 2 kind of strategies. Those are 2 like extremes, where it's lean on one side and really full on the other side, between lazy loading and write through caching. There are obviously tons of varieties between those 2 extremes, right? What we used to do, by the way, is we did a thing where we would preload a cache every time it started with the data sets that we knew were relevant. And we also had in the application a flag whether that data was going to have a write cache action added to it or not, because only certain data did I actually want to be written to the database, and we had identified what those data types were. But that required changes in application logic, and I just want you to be prepared for that. There's no pass-through caching that's invisibly done for you. By the way, there are systems out there that will do pass-through caching for you. I'm trying to think of like teleport, like the teleport database proxy would do that kind of thing, right? So, but just be aware, Elasticache doesn't. This is all being handled by the application, your application. It's managing the caching. Okay, like I said, short dip into Elasticache. That's all it was, right? Okay, so now here's the check. So true or false? Consider caching when data is accessed infrequently. Is that true or false? Is that when you want to consider caching? Good. Yeah, it's definitely not true, right? When we want it when data is frequently accessed, that means we get reuse right out of it, right? All right, true or false? Memcached offers multi-threading where Redis uses single threading on a per core, like multi-core system. Yeah, that was the key distinction. So good to see the answers, right? Is that it's a key distinction is that Memcache, despite being very simple and not having advanced capabilities, does actually multi-thread. Redis is single thread. All right, only Redis provides multi-AZ with auto failover capabilities. Is that true? Like from a replication, like a cluster set, does it actually, is it the only one that provides multi-AZ failover? Yeah, I did make a big deal out of it. It doesn't. It doesn't. It does have it actually, whereas Memcache doesn't have it out of the box. All right, so here's interesting. So time to live is an integer value that specifies the number of seconds until the data key inside the cache expires. Is that true or false? Is that what a time to live does? Does a time to live say when data expires inside of a cache? That's true. Good. All right, number 5. The write-through strategy adds data or updates data in the cache whenever data is written to the database. Is that what the write-through strategy is? Does it update the data in the cache every time we write to the database? Is that true or false? Yeah, that's exactly right. Write-through says, look, when I write, I'm going to write through. So I'm going to write through the cache, which means I'm going to write everything I write to the database. I'm going to write it to the cache. Good. All right, last but not least, does Memcache include pub sub capability? Remember, Memcache is very simple, has no advanced sorting, ranking, no replication, none of that stuff. So in this particular case, your answers are all right. It's false. No pub sub capabilities here. Good. Questions of any type around Memcache, caching, any of those pieces? Okay. Let's talk for the remaining time that we have about developing secure applications. So I'm not to insult anybody's intelligence. This is a random, from my perspective, a random gathering of things that Amazon wants you to think about like securing your applications, about authenticating, so this is just a random collection of just things they want you to think about. So just roll with me. Obviously, there's more exhaustive lists to this whole thing. Okay. And of course, there's some marketing aspect to this because obviously we're going to talk about services that solve certain problems. So one of the things to note is that managing SSL certificates is not fun. It isn't, right? Not only just the cost, but the rotation, the renewal of certificates. How do you do that on a programmatic basis? How do you securely distribute those keys, right? And we're talking particularly about HTTPS keys, basically. Like these are the SSL certificates, TLS certificates used to encrypt like traffic in transit, right? Not at rest, transit, meaning websites or any kind of web traffic. So this is where the ACM, the AWS Certificates Manager comes in. is that this is a service that allows you to provision, manage, and deploy basically private and public TLS and SSL certificates, right? For both your public and your internally connected resources. So with ACM, from a programmatic standpoint, you can literally just request a certificate, deploy it on an AWS resource, such as a load balancer, CloudFront, EC2, API, like API gateway, it doesn't matter. It also allows you to create private certificates for your internal resources, and it allows you to manage all of these certificate lifecycles centrally. Public and private certificates are provisioned through ACM, and you only pay for the resources that you create to run your application, right? So just to say this, for private certificates, you do pay monthly for the operation of a private certificate authority and any private certificates you issue. Obviously, if you have public certificates, those come from a public certificate authority, Amazon in most cases, or whoever they're using, right? So you pay for those certificates. Now, the other thing is that, okay, so in addition to managing data in transit, right, connectivity, and you want to secure that, this is one service as an option. What are other services that could be used for data at rest, especially sensitive data like username and passwords? So Amazon actually has two services for this. One is called the Systems Manager Parameter Store, which allows you to do secure strings. But the other service called the Secrets Manager allows you to basically rotate and manage database credentials, API keys, all kinds of username and password items through this whole like secrets lifecycle. And it can actually, Secrets Manager can actually rotate like username and passwords for you, so that as an application like boots or restarts, it can actually get a new secret, or if it just periodically checks for a new secret, you can actually have the Secrets Manager do a push against your application and say, hey, by the way, you got a new password, update this, right? So this avoids you having to deal with secrets in either configuration files or in repo or any of that stuff. So Secrets Manager allows you to host and publish and renew and rotate these like secrets, like a username and password or API key, right? So in this particular case, you've got your code where when it starts up, it's got the proper permissions to basically call Secrets Manager and ask for a very specific secret. That, like in this case, the database credentials are returned to the code and then allows it to establish a connection with the database that you're targeting. And by the way, when the database changes and the secrets are updated between the services, it actually will update the application and even push on it, do an HTTP post and say, hey, we've updated this. Or if the system polls on a regular basis, it will say, hey, the password changed, right? So it just depends on how you set up your application, your architecture. So this is Secrets Manager. Secrets Manager is basically a little bit like, you may be familiar with Vault. There's like tons of other tools out there that basically acts as a secrets repository. So this would help with data at rest from an application standpoint and data in transit from an application standpoint. Help, by the way, not completely and utterly solve. Okay, so beyond the ACM, the Certificate Manager and Secrets Manager, other things to consider, right, is that when you want to authenticate your app to, to IAM, having a service count like with an access key and a secret key, that's the kind of the old way of doing it, but it's still the appropriate way to do it if you're not necessarily on AWS infrastructure. The preferred method is, you could use get roles via the secure token service, which is basically what we're walking away with here, is that roles are typically the preferred way now to give on-premise, or sorry, on cloud, applications AWS access. So this is the way in which a cloud-based application can actually get permissions, right? It's just request a role through either STS, and you can either do that through local loopback against an EC2 instance. You can do that inside of a container. Obviously, if it's Lambda, it's already getting a role, so like it's all good, right? Now, that being said, most people don't know about the secure token service, right? This is a stub of IAM that basically has been around almost forever, and it supports SAML assertions, OIDC, like Federation, but it basically allows you to request an authenticated security token from IAM if you have permissions to do so, or if you're federated with AWS. And you get to use, basically policies attached to roles to control what tokens can be requested by whom and how, right? So there's no limit, by the way, on the number of temporary credentials that can be exposed. I think you're limited to a couple hours on the token that you're allowed to retrieve. Here, by the way, we've got a corporate data center. And what's happening is that maybe, there's an identity broker here already in some form or fashion. And so what's happening is that the users who are authenticated here might be asserting that they have a certain role, and STS recognizes the broker as a trusted source. So it might return temporary credentials and then grant access to services. But you can make an assertion at any time, assuming you have the right permissions and authentication or token, to say, I want to assume like an administrator role. And if you have those permissions, you've got them. So you can actually get access to the services that you want. Now, when you get the token back, it's going to have basically an access key, a secret key, the session token itself, and it's going to contain an expiration, which actually it says it there. It can be up to 36 hours, right? So when you make a call to STS right now, at least it all goes to Virginia, basically, right? So the secure token is available as a global service. All of the requests go to a single endpoint. The global endpoint, by the way, maps to the North Virginia region. Regional endpoints like Oregon and all the others are activated by default, except for US East. Everything you do against STS does show up in CloudTrail if you've activated CloudTrail, and credentials that you get are global, just like they are in IAM, which means that when you pull down an STS token to get authentication, you can use that token across your account anywhere in the world. So, just know. Now here, by the way, you've got an identity broker application on the left-hand side, and it has permissions to access STS. There's like a trust relationship in a sense has been created between the two. So the identity broker, so what happens is the first thing that always happens, no matter if it's Google or Facebook or your own corporate thing or Active Directory, is that the user has to authenticate with the third-party data store first. Then once the user accesses the broker and authenticates, what then happens is that the identity broker, whose job it is to broker the identity for the user, is going to basically go over to STS and say, hey, by the way, this user authenticated with me. We have a trust relationship, so I need a credential. Well, what will happen is it's going to return a key, and then it's going to redirect the user to the console, which is then going to basically allow them access, because it's going to give them basically a token that, or an STS entity that will basically allow them to get into the console, but only after STS has verified its relationship against the identity broker. No relationship between STS and the identity broker. STS isn't going to allow anything to happen because that's not connected authenticated information. So you can use roles via the STS service. You can also federate, which is basically what we're talking about. So you can throw an assertion against the STS service, and then of course you can use identity federation, and anything that is SAML or OpenIDC compliant 2.0 compliant will actually work with STS, right? So this can give external identities an account. It could be Active Directory, it could be ForgeRock, it could be ping federated. It doesn't really matter, right? As long as there's a trust relationship or authentication information in the assertion that's sent over to IAM, to STS. Let's see, SAML will allow you to do single sign-on. You can manage everything centrally. There's not much more to say about that. It does work once it's set up. Here we are doing single sign-on federation using SAML. Once again, notice that the user has to go over into their portal and log in first. That's always the first step. the first step is they have to authenticate and log into their respective data store. And then they receive the SAML assertion from the identity store, which is then posted over to AWS's STS, right? And then what happens is then a token's kicked back and then they are redirected to the management console in that same session with the right information necessary to access the management console. So think of this is that like you have to connect these things together. By the way, you do have to generate with your identity provider software a metadata document and create a SAML provider, and then that metadata document has to be submitted over to AWS. So you are actually exchanging security and connection information with AWS prior to any of this going forth. So just note that you have to connect your identity systems together before something like this would actually function. And by the way, if this is Active Directory, you can actually map your Active Directory groups to specific roles. So you can actually map them to a wide variety of roles. The admin group in Active Directory could be mapped to an admin group, role over in IAM. Your developer group over in Active Directory could be mapped to a developer role in IAM. So just know by default, just because you connect Active Directory together with AWS doesn't mean that everybody in there gets unfettered access. You actually have to specify who can actually do what. By default, remember, by default, AWS always says, no, you don't have access, right? So just be mindful of that. So here we are federating. And then probably the last thing is just Cognito. So everything that we just talked about is basically us federating like corporate identity providers in with AWS or a web identity provider in with AWS. And obviously, what if you have like mobile users or web users and you want them to actually have their own username and passwords that are not AWS passwords, because that doesn't really work. Like what if you need an application data store? Well, this is where Cognito comes in. Cognito not only has a bunch of features like, syncing mobile data and saving app preferences and mobile identity management and all that stuff, but it will actually allow you to do web identity providers like Google, Twitter, Apple, etc. It'll allow you to do your own identity system. It will also allow unauthenticated guest access with very limited scope. So basically, Cognito basically takes care of all the steps to create a unique identifier for your application's users. And then you can actually associate those like users with AWS access. So Cognito is great if you need authorization and authentication for web and mobile users, and whether you just want them to authenticate into your app or you want them to authenticate into the app and get AWS permissions, it's all in here. It's available, right? So a user, by the way, who's authenticating here will actually hit their login provider first. Let's say it's Twitter or Twitch. They'll get back some authentication information like a token, right? Then they'll basically go over and say, okay, let me kick out a get ID API call first to establish a new identity with Cognito. And so what's going to happen is it's going to generate a Cognito ID, right? That's going to get validated against the login provider, because when it goes to get an ID, it submits the information it got from Twitch in this example. So Cognito is going to take the information that the user supplied from Twitch, and it's going to go talk to Twitch and say, hey, by the way, is this person who they say they are, right? If all of that validates, then what it's going to do is it's going to submit data, like a validation, back to the app, and then it's going to get credential. Like the next call is going to be, hey, I'd like to get some credentials for my identity. It's going to validate again. It's going to request to assume a role, and then it's going to return credentialing all the way back to the device. And this is going to happen really fast, right? So federate with your third party first, talk to Cognito, validate that the identity is real, then ask for some credentials to get access to AWS, and then return those credentials back to the end role. And then you basically get secure access from that point from the access and secret key and the token. Does that seem like a lot? That does seem like a lot, actually. All right. Now, if this is a developer authenticated, like some people might want to do their own identities instead of a public identity provider. Cognito makes this like really easy to do by using an open token for the developer identity. So let's say that there's a user authentication system, doesn't matter where it's running, but the end user is authenticating against the system. The system basically talks to Cognito and says, hey, can I get an open ID token? OIDC token is returned. It's then submitted back to the user. Now, let's be clear. There's a trust relationship between Cognito and the developer identity provider, the authentication system. The OIDC token pool ID and different role arms are requested against Cognito, which then in turn returns the roles requested if the user has permissions. And then basically access to AWS services is granted or denied based on whatever role was requested. We're done at that point in time. Everything's working. Questions? Okay. So how do we then continue to authenticate our customers using Cognito, right? Well, we've talked about a lot of this already, but basically the user pool is and identity pools are the two core elements for Amazon Cognito. So Cognito uses these user pools to basically successfully assign an identity and authenticate who the user actually is. If you want to authorize them against an AWS service, you actually have to use an identity pool. Is that right? Oh man, I got that confused in my head again. Hold on. So let's make sure. User is basically directed to authenticate. You determine the identity provider that you're going to use. Then you go back to the identity provider. The user is then authenticated. That's right, by the identity provider, which is number 4 up here. And then what happens is the identity provider is going to post back to Cognito with a SAML assertion. And then the profile is updated with the SAML assertion, any like session token information. And then Cognito is going to provide the token to the application, which then allows the token at that point in time to be used, potentially to get access to AWS services if you've set it up that way. Notice here that the user is still first authenticating against the identity provider. That's always the first step, is register against Facebook first, register against your identity provider first, log into Active Directory first. That shows up on the exam on occasion where it's like, what's the first step whenever you need to like authenticate with Cognito? It's like register against your identity provider. Now here's our scenario, which we were looking at before. We've got a website and 2 S3 buckets. We've got an API gateway that's handling CRUD operations against a bunch of Lambda functions. And then we've got Cognito over here handling authorization and authentication for our end users against these websites. So all perfectly sane and perfectly valid at this point in time. All right, let's do a little bit of a wrap up. All right, true or false? You can download the private key generated by AWS Certificate Manager. You cannot download the private key, actually. That's just something to know. You just can't download the private key, right? Let's see. The AWS Security Token Service temporary security credentials can be reused after expiration. Is that true? Can you reuse expired credentials? No. No, you cannot. Okay. Third one. AWS Secrets Manager can rotate your database credentials. Can Secrets Manager rotate your database credentials? That's true. That's one of the great benefits of Secrets Manager is that it can actually rotate your credentials. All right. Fourth, Amazon Cognito federated identities can be used to store username and passwords for your customers. Store username and passwords? No, Cognito doesn't do that, right? It's not a data store. You can authenticate against it. You can actually use your own data store. It's not really going to store username and passwords for your customers. All right, last but not least, SAML and OpenIDC is more complicated to implement than AWS STS. Are these open standards on authentication and authorization? Are they more complicated to implement than AWS STS? I wouldn't even really know how to answer this one, honestly. I'm like, I don't know, maybe, are they? I have no idea. I would say that Amazon would probably want to say that this is false, right? They don't want to think of one of their services as being more complicated than the standards, right? So false. All right, that's it for that. So here's where we're at. First of all, floor is open, questions of any type. Okay. All right, so for the rest of the day, here's what we're doing. Want to see the back end here? This is what we're doing. So we're going to be basically talking about deploying applications for a little bit, and then we're going to roll right into your capstone lab, and then there's a little bit of course wrap up. Now, here's the cool thing about Liberty Mutual. You guys have your own course evaluation, so I'm not going to give you one. I'm just going to have you do the one that they ask you to take, right? In addition, the course wrap up is where I'm going to actually talk about the resources that I'm going to send you in an email in the next 24 to 48 hours. That basically includes everything that, all the trainings, any of the ramp up guides, any of the stuff that we're talking about. Okay. So open floor for questions. Okay. Well, then let us do this. Is that let's go ahead and stop for lunch. It is now 11:50. So let's come back at 1:01, just like we did yesterday. Let's come back at 1:01 p.m. And then when we come back, we're going to talk about deploying applications. That'll probably run us for like the first hour. And then at 2 o'clock, we're just going to roll right into the lab. I'll go ahead. Sorry about the pre-warming. That took way longer than I thought. I'll make sure that I pre-warm the labs right at the top of the hour when we meet next time. You'll have 2 hours to run through that last lab. And then we'll spend the last 30 minutes of the day just covering like the additional material, the training material and whatnot. And in there, we'll sneak in the course evaluation so you can get that all kicked off. Okay. So right now, unless there's any other questions. No. All right. There's no other questions. Then let's just be done a little bit early. So 1:01 p.m. I'll put a timer up, but we'll see you in about an hour and 10 minutes. Okay. Have a good one. All right. So here we are. I love that there's like an introduction to DevOps here, right? I think at this point, if you probably haven't heard of DevOps, you might be purposely avoiding it, which is totally fine, actually. But just know that we're going to talk about DevOps a little bit about general thoughts about how AWS likes to think about deployment and testing strategies. We will talk about Beanstalk, but I just want to say a caveat here. Beanstalk is a great place to start. It's not a great place to stay. It's basically a wizard for EC2 virtual machines. So it actually can also do Docker containers, but it does allow you to deploy your code into virtual machines very simply with, some, level of sophistication. And then we're talking about wrap up course scenario, and then we're actually going to do a whole capstone lab. So just a reminder, I'm going to tell you when we get to the labs is that make sure, particularly with the capstone lab, that you are ensuring that the console is not jumping around our regions on you, right? So just a reminder. I'll say it again later. Okay, so introduction to DevOps. Okay, so when we're talking about getting your application running, one thing to think about here is that your application is really not just your application. If you have a running product that is to be consumed by people, then the thing to know and remember is that your application is the code plus all of the infrastructure required for it to run, right? That's how the product gets consumed and out to consumers, out to the public. So it's a requirement. Now, DevOps's goal is to basically remove any barriers that prevents a team from delivering agile, compliant software speedily into production. And I don't mean agile as in capital A. I mean agile is just agility, right? So DevOps as a rule is trying to bring all of the chefs in the kitchen together, whether it's the business owner, the architect, the coder, the tester, the security person, the operations person, and the support people. Let's get them all together. We're going to do a product. Let's get all of the concerns from requirements to building to testing to deploying to maintaining. Let's get them all in a room, because, you know, like, for example, security is often an afterthought, but you can't put eggs in the cake once you've baked the cake and there's no eggs, right? So sometimes it's more costly to try and rebake that cake because you forgot security, or you forgot support concerns, or you forgot operational concerns. If we start it from the beginning, it may sound cumbersome, but it's a little like pair or mob programming. It's a really uncomfortable practice that usually yields incredibly high quality. And if all of our first deliveries into production are right on target because they have all the concerns attended to, then guess what? We win, right? Quality meets the benchmark. We don't have to worry about security concerns as much. We don't have to worry about operational concerns as much because they were baked into the inception of the application from its beginning requirements definition. So dev and operations coming together, dev security and operations coming together, dev security operations and machine learning coming together, architects coming together, business owners coming together, support people coming together. It's, you know, it sounds like a big kumbaya fest, but I've operated on tons of teams where all of those concerns are represented and the software quality is absolutely through the roof, right? It's right on the mark for the customer and for all the people involved. And so there's this kind of shared accountability, shared responsibility model where even though it crashes in production, the developers go in with the operations people. There's a security incident, they go in with the security folks. If someone's having trouble testing, everybody gets on it. You might think, well, that's a waste of time. No, it's not. All that information and knowledge is shared. So then next time the operations person needs to support a security goal, they may not even need the security person there to make that design decision. And then they can surface it back to the security person just to make sure that they met the goal for security, as an example, right? And so that does require a lot of visibility, communication, and transparency. But at its end, it's really about removing any barriers on people, any barriers on process, and any barriers on technology that prevents you from delivering swift and compliant software. Notice I said compliant. So microservices and infrastructure as code and CI/CD, these are all part of it. But as a cultural battle cry, the focus is on how do we create connections with people. From a process standpoint, it's about these kind of design patterns about microservices and CI/CD and infrastructure as code. And from a tooling standpoint, it's about using the tools that your team is both familiar with, but that also enable things like infrastructure as code, CI/CD, microservices, etc. These really scalable cloud native patterns that do add some complexity, but the price of, like, the benefit of that complexity is that you can add a tremendous amount of flexibility and agility. That was a lot of talking. So AWS, by the way, has a bunch of code services that they want you to look at in this area. But at the heart, it is about removing all barriers that prevent the delivery of compliant and, like, you know, agile software delivery in production. Now, you heard me talk about this, by the way. Wow. Let's try that again. Is that, you know, like, here in a sense is almost like a release phase. It's also kind of like an SDLC, right? Software development lifecycle. What's kind of missing here is obviously requirements gathering and design. But then sourcing, building, testing, deploying, and monitoring, you know, typically those become roles. Like sourcing and building becomes like a developer's job, and QA becomes a tester's. Testing becomes QA's job. Deploying becomes, you know, DevOps and or system admin, system engineer's job. Monitoring also becomes a sysadmin, system engineering job, or it could be a support person. what we're trying to do is we're trying to get all of that so that everybody participates in every level. Because if all of a sudden you got a developer involved in maintaining a system, guess what happens to any bugs that are production faulty? You wake up a developer at 3 o'clock in the morning because all of a sudden their software is buggy. Guess what happens? That bug gets fixed and prioritized typically, right? If something's not testable, right? And maybe it's an environmental problem, it's not a code problem. Getting the operations person involved in the what that caught, like that failure of that test, is an amazing thing. So just know that it sounds very kumbaya and very like idealistic and pie in the sky, but most cloud native companies operate with cross-functional teams that run through all of these SDLC life cycles. There's no more siloing against technology. Everybody is siloed against a product, right? So here, by the way, in terms of like what the major components are of these phases, this could be, for example, checking in, whatever. Then you can kind of build things. This is where you might also like compile code, check style, check syntax, maybe even like run your security scans, run your unit tests. Then you can have integration tests, smoke tests, load testing, UI tests, penetration testing, regression test. Like you can add all kinds of tests in this phase. Then you get to deploy to production, which, by the way, in the build and testing phase, you actually might deploy to dev and testing environments as well. And then once things are launched into production, you're going to monitor it. Who's going to patch it? Who's going to maintain it? Who's going to make sure that you can quickly detect any kind of problems, whether it's a security problem or an operational problem, right? Now, CI/CD has kind of like a couple of different phases. So continuous integration is the act of merging small batch changes into a deployable branch. That could be main or master or whatever we're calling it now, right? Or it could just be a release candidate branch or a release branch. That's up to you. And so integration is the ability to take those feature additions, those changes, test and make sure that they're not breaking anything, and then putting that on a release branch, right? Continuous delivery is the act of taking the build artifact from that CI merge that's all tested and whatnot, testing it to death, and then getting right to the point where you could deploy it. Notice that little gate there, right? That's continuous delivery. Sorry, my brain always fails on this. Continuous deployment is where you don't have a stopgap. When you commit to code, it goes through all the tests, you trust everything. And like Google, the way Google does it is they actually like immediate deploy a percentage of their traffic on the new version. If the errors don't start mounting, if they like test 0.5% of their traffic, then they roll it to 1%, and then they roll it to 3%, and then they roll it to, and they just keep going until that new version eats all of 100% of that production traffic. So just note that continuous deployment is actually where you're deploying all the way into production. Continuous delivery usually has a gated mechanism to it, which says, I'm ready to deploy to production, but I need something else to happen first. So here, by the way, is where you've got a developer on the left-hand side, and they're committing to a central version-controlled repo. And then what happens is that there's a CI/CD server, which you can actually see here, right? Let me pull this up for some little annotation so I can actually refer to this. So developer comes in first, then we're going to commit to repo into version control, and then the build server is either polling or the version control system tells the CI/CD server, like a Jenkins, for example, or Bamboo or whatever. There's so many options here actually nowadays. This CI server, by the way, is going to like run the build, run tests in parallel. And then, by the way, it's going to send a build report to the developer. Say, hey, by the way, everything looks good. If everything looks good, then it's going to take the artifact and push it usually to a third-party repository. And by the way, it also might pull configuration either from the environment or from version control. And then what will happen is it's going to build the packages, the artifacts in question, make sure that they are like committed to that artifact repository that we're talking about, and then store the package. And at this point in time, this package can now be kicked out to production. Now, what's missing here, just to say this, is that you could actually kick this package once it's built out to some kind of testing or development environment for like further testing, actually. So if it's not going to production, it's not continuous deployment, but continuous delivery could actually include environmental deployment. So just something to be clear on. So deployment goes all the way out, delivery stops right before production. That's the main thing for you to remember. When most people say CI/CD, they're talking about stopping right at the production line. They're not talking about keep going, right? Now, notice that most of this was just developer side stuff for the most part. It really was. Don't get me wrong, the build process is probably going to be owned by a release manager, not necessarily by developers. And there might be some kind of DevOps SRE guy who's handling all these pieces. But notice that we haven't really talked about environment creation for either dev, test, or production at this point in time. Hold on just one second. Make sure that everything was good there. So what about more complex environments, right? Like one thing to say is that even if it's a simple environment, frankly, you should be writing your like virtual machines and all that infrastructure as code. You know, most of my stuff is written in Terraform. I just do, you know, Terraform apply. It says, are you sure? I say yes, and it just spins up everything. You can do the same thing in CloudFormation, right? I just use Terraform because it's cross-platform, so I can use it for any cloud provider, right? Not the same files, just that I can use the same syntax for different systems. Now, Terraform or CloudFormation or even Pulumi, or if you decide to use CDK, which is Amazon's cloud development kit, all of that can be checked in a repository. You know, the real push now is that if you're a sysadmin, you are using software engineering disciplines to actually write your infrastructure as code. And just to say this, if you're in the tech field and you're not actually at least conversant on how to code, just know that that's where everybody in the industry is headed, right? Everything from machine learning to database engineering to even infrastructure engineering, it is all headed towards code. I was fighting it for years. And then, you know, like, I don't know, 8 years ago, I was like, I got to stop hacking away and become a little bit better at writing Python, right? And, you know, now my Perl is a little rusty. Python's strong, Go is strong, Rust is getting stronger, right? You know, I didn't get in the industry to be a programmer, but guess what? If you're going to stay in the industry, you're going to need to become a programmer. You at least need to become conversant with JSON and YAML and, you know, some of the DSL syntax for infrastructure as code. But if you want to stay long-term as an infrastructure engineer, you have to learn how to code. And I don't mean a feature programmer. I mean, you have to be conversant with code, at least at a base level, right? Manipulating, transforming data sources, data sets, etc. Now, Amazon, outside of all these concerns around DevOps and CI/CD and running infrastructure as code, wants you to know that they have a bunch of tools called code something that basically replace everything that you see in this kind of thing, right? So they've got something that will host version control. They got code commit. They got something that will build stuff called code build. You can actually create a pipeline, like it's almost like a CI/CD server using code pipeline. They've got code artifact if you want to host your artifacts into a third-party repo. They even have things that will do machine learning algorithms against your code, like Code Guru, right? So just know there's a bunch of services out there: code build, code commit, code pipeline, code deploy. Forgot deployment, right? So you can use code deploy to deploy. And just to say this, code deploy will work off of AWS as well. You just have to install the agent on your system and have some kickback, some connection back to AWS. But code deploy will actually deploy on on-premise servers if you want it to. Now, CodeStar, by the way, which is up at the top up there, is like an orchestrator for all of this if you just want to like have it all kind of like done for you. Code Artifact is not listed here either. Code Guru is not listed here. There's a couple other services that are not listed here. X-Ray and CloudWatch, we already talked about. X-Ray does tracing and CloudWatch does monitoring and metrics, obviously. Now, a couple of other things to think about other than just knowing that Amazon has a bunch of code services. And to say this, I don't know how popular these are going to be with an existing on-premise crowd, because quite frankly, we already have this solved, right? We've already got GitLab and Jenkins and Bamboo, and we've already got like our own Bitbuckets and our own, I don't know. But anyway, they are here. They are actually, some of them are pretty robust, so they're not bad services. We've already solved these problems, but just know that they're there. Okay, let's talk about some deployment strategies. So in addition to kind of like, obviously all of these kind of front SDLC concerns, what about deployment strategies? So just know that, one common thing is like a blue-green deployment, which is basically where you cut over from one version of an app to another version of an app, right? And so one is blue and one is green. I can't remember where the terms come from, but I remember seeing an explanation for it one time. But blue is the existing environment and green is the new one that you're going to. So in this particular case, right, you've got Route 53, which is a DNS service, and 100% of the traffic is going to the system over to the left on the left-hand side. That's your blue. That's your existing production environment. In a blue-green deployment pattern, you keep the old environment up and you literally just copy the whole thing, but you've got a new version of your application, which, by the way, may also include schema changes to your database. And you cut over to a new version, right, of your app. And so 100% of your traffic is now going to green. If the migration completes successfully, you might want to keep the old stack up for a day or two and then just delete the old stack, right? So, and if you're using infrastructure as code, it's going to be a one command line execution to delete that entire stack. It's also, by the way, if you're using infrastructure as code, it's going to be a one command line execution to stand up a whole new stack. So this is a good reason, by the way, to have repeatable templatized infrastructure as code deployments, because you're going to be building these environments repeatedly and tearing them down. Remember, we treat these as ephemeral. We don't treat these as permanent or persistent. The day of persistent servers with naming conventions and whatnot, those days, oddly enough, should be over. It doesn't mean that you don't have services that need to be consistently up, but you should be able to recreate them, which is what this is highlighting. Now, in this particular case, you could actually, like if you were using auto scaling, you could actually modify the launch configuration of your auto scaling group. And so notice that you've got only 4 boxes in your group at the bottom. You could launch an additional 4 boxes that have the new application on them and then have them mixed in with the traffic. And if there's a problem, you just set a new launch configuration and get the old one back in, right? Just to be careful, you have to be careful with this though, because this is mix and match deployment. So you got to set up monitoring to verify the new instances are healthy, right? So a little bit more complicated, not as clean cut. Notice in this case, what they're doing is that they are transitioning, right, to where they're getting rid of the old systems, the old version, right? So initially there was just the top version was the new version. I'm sorry, the top version was the old version. What they're doing is they're adding an additional set of systems and they're getting rid of the old version, which is what they're showing here in the slide deck. Now there's also, so that's a cutover strategy, right? That goes like you just cut over to a new version, right? That's blue-green. There's also an A/B deployment strategy, which is also known as the canary strategy. Sometimes it's called linear, which basically is you give a certain percentage of your traffic to the new version. And this is what I was just describing this with Google. And like, for example, environment B here has 5%. And if there are no errors, then you just cut over to the new environment. Now, this is a little too like tested for me because they're only doing 5%. I would probably do a linear deployment where I went from 5 to 15 to 30 to, that kind of thing. Here, by the way, what they're doing is they just cut over. They're like, hey, 5% looks good. Let's just put the 95% traffic on there. The reason I prefer a more linear canary deployment is because all things break under scale. If I stress you out, that's when I will see your personality flaws. Same with me, right? If I stress the system, that's when the system's going to show its cracks, right? But going from 5% traffic to 95% traffic is probably a little too aggressive for large scale systems to actually, unless you just want to break them, right? But if you go from 15 to 30 to 45 and you keep kind of like stepping it up every couple minutes, you can watch the system adjust to load, right? So compared to blue-green, which is just a cutover strategy, the A/B deployment strategy, which I also call toe in the water, is like you testing the waters a little bit first, is also known as canary in the coal mine or linear strategy. Any questions about blue-green, CI/CD, DevOps, infrastructure as code, or any of that stuff we just covered? No. No. Okay. Let's talk about Beanstalk. So Beanstalk is an AWS wizard for deploying your app. So it's very similar to Lambda, except it's built for virtual machines. Now, don't get me wrong, you can deploy the Docker containers, but you give it a zip file or a Docker container, and you basically say, go deploy this, and it asks you a bunch of questions. This is not like Lambda where there's a simple set of questions. This guy is going to ask you, how many servers do you want? Do you want a traditional triple app? Do you want Tomcat? Do you want to use Blowfish? Do you want IIS? It asks you a bunch of stuff. It's really designed for Java and web-based applications, but quite frankly, it has a large number of runtimes that it supports, ranging from PHP to, I think .NET's in there. Don't quote me on that one. Java and others, right? So you just give it the code, you choose the architecture, you can even instantiate an associated database. And a lot of developers will use Elastic Beanstalk to get started, especially if there's no one there to support them on virtual machines and help them administer and orchestrate these things. I give you a great example. Equifax, with their whole data breach, the government mandated that they actually rotate over to cloud because their data centers were so faulty that, hackers were just breezing in, right? That was all public knowledge. So, actually it says .NET right there. So there we go. Maybe I should read the slides. So just know that when they did the initial migration, they were in such a hurry because the government mandated them to get out of their data centers that they had to migrate using Elastic Beanstalk. And now, a lot of their chief architects who I'm aware of are now having to basically do a post migration because it achieved the short-term goal, but long-term, there's a tremendous amount of inefficiency with using Beanstalk because it doesn't support customizations. It doesn't support a lot of advanced functionality, such as containers and stuff like that. Now, doesn't mean you can't host Docker containers, but it won't run them in ECS or EKS. It doesn't support that, right? Notice that PHP, Java, Python, Ruby, Docker, Go, .NET, Node, it's all listed there. So it supports a wide range of runtimes. Perl used to be on there. Not that anybody's using Perl anymore. I use it for system administration every once in a while, but not otherwise. All right, so Beanstalk is a wizard. You give it your code and it will set up EC2 instances for you in a configuration you specify. Now, the goal of Beanstalk is just to help developers deploy and maintain scalable web applications on EC2. That's it. It will set up things in an auto-scaling group. It'll manage the operating system for you. It'll install the interpreter. It'll do all that stuff for you, which is what it's there for, right? So you define the environment, different application versions, and then, any kind of application configuration, any operating system configuration. You can specify all that, right? You can specify an environment that's either a web tier or a worker tier. You can actually have messages sent and integrated into an SQS queue. You can actually set those virtual machines to be auto-scaled behind a load balancer. Application code is stored in the S3. It, by the way, automatically supports blue-green rollouts with DNS failover automatically included. So it actually does some really awesome things, but when you get to, like I said, to certain customizations, there's some limitations. You can't have multiple environments, right? And like a test environment and staging and all that stuff. You can actually add multiples if you want to. Just note that there is a command line tool that goes with this: ebinit, ebcreate, ebdeploy, ebdelete, right? And it provides an automatic DNS entry for your application that changes when you move the application to a different version or a different environment. So it basically has a little CNAME for that. Beanstalk works remarkably similar to Lambda, or rather I should say Lambda works similar to Beanstalk because Beanstalk has been around for over 10 years. And has gotten so robust, right? So it really is a decent product for what it does. But notice that the machines that are hosting the application get a role, which makes sense because that's what we've been doing the entire time. Also know that if you want Beanstalk to do stuff on your behalf, like create SQS queues or DynamoDB, you have to give Beanstalk a service role so it can do those things, right? So just like Lambda, there's something that defines what Lambda can do, right? In this case, it's a little different because these are virtual machines. You also have to give the virtual machines permissions. Beanstalk, by the way, will create these roles for you if you don't specify them. So it's not like you have to have them predefined. It will do it for you if you want. How do you access AWS services from your instances? Let's say you want to have the S3, you just have to add permissions to the servers, right? So in this case, you would go back to the instance role and make sure it had S3 permissions added to it, right? That's it. Just that simple. You already know this. You know that roles associated to services or would allow that service to talk to other services. You can customize the default environment. There's actually in like the in the deployment file, you can actually create a config.yaml under a .eb extensions directory. That's kind of all mushed up and mangled. Weird. But you can actually specify an environment configuration file. You can configure like repo packages. You can set environment variables, right? The config.yaml is bundled up with your application when you deploy it into Beanstalk. So it reads this file and you can use it to configure your instances. You can configure related services. That config.yaml is actually pretty powerful. Read the documentation, right, on customizing like containers in Linux and Windows with Beanstalk if that's something you're interested in. Here's an example of the config.yaml, right? Some environment variable options, right? Packages that you install in your instances like Git or Python or whatever. Although if you choose a Python runtime, it'll do that for you. Here, generating other artifacts required by your application. They're using Rake, which I typically only use with Ruby, but I know you can use it with other things. Interesting. Versioning with Beanstalk is really interesting because you can actually just do an EB deploy -- version and specify the version, and it will literally deploy a new version of your app if it's in your path/repository. You can also swap environments where you like clone an environment, like clone an app, and then deploy right the app, and then swap an old version like version 10 with a new version, right? So you can actually just point it if you want to instead of doing an in-place upgrade. The left is an in-place update. Sorry, and actually I realize it says that. The left is an in-place update, which means you're replacing the app on those instances. The one on the right is more like a blue-green deployment. You've got an old environment and you're like pushing in a new environment. And that URL, that myapp.example.com, that's what changes. By the way, you can put a custom URL there. It's basically just a CNAME to the original AWS URL. And that's Elastic Beanstalk. Let's test the knowledge of that little fire hose that we just ran through. All right, so DevOps is a methodology that requires collaborations, not collaboration, but collaborations between teams involved in a product. Does that sound like what I was describing before? Or did I say, we need to go to war with all the rest of the teams? I can see I got one reply initially, so maybe I scared everybody. Yeah, so actually, that's true. I mean, it's about cats and dogs in harmony with each other, the sun and the moon coming together. I'm just kidding. It's not really that kumbaya. It's really just about getting everybody who's involved with the success of a product on the same team. So it's less about being siloed with your security team or your operations team. It's just about getting them together, right? I love this statement. Nearly all release processes, I'm going to replace a word here, could be simplified down to 5 stages: sourcing your code, building your code, testing your code, releasing that code to production, deploying it, and then monitoring your code. Is that true? I feel like that's a good fit for most software development life cycles. That's actually true. Actually, you could distill them down to that. Okay, let's see if this makes sense. DNS cutover, which is just pushing the URL to another IP address, and swapping auto-scaling groups are the 2 most common methods used to reroute traffic in a blue-green deployment model. Yeah, that's true actually. Right, changing DNS, and then we saw earlier where I actually like swapped in different auto, like added in new launch configurations into an auto scaling group. Sure, that absolutely can be done. Okay, fourth one. AWS CodeStar compiles source code, runs tests, and produces software packages that are ready to deploy. Is that what I said CodeStar did, or was there another service that actually did that? Is that true or false? That's true, actually. Well, hold on. Sorry. I lost my train of thought there. That's actually not true. So CodeStar doesn't actually compile source code. CodeStar orchestrates all of the other code services. So it gives you like a templatized kind of best practice way to use all of the code services. Compiling source code, running tests, and producing software packages is actually code build. Code build is the one that does that, not CodeStar. Okay. With Elastic Beanstalk, new versions of your app can be released onto an existing stack, and you can do a rolling update. Is that true or false? Can you roll release out new versions of your application? Because we know we can do in place, but can we also just roll out a new version one instance at a time? Yeah, that's true. We can do that. That's not a problem. We can also create a new environment and just cut over one version to the next. We can do all kinds of stuff, right? You can do in-place upgrades. You can do a rolling update. You can do a rolling update with additional batch, which is where you actually add additional systems and, roll them all out. So that way there's no loss of like capacity. So yeah. Okay. This question I just find to be very weird, provocative. In an A/B deployment strategy, the deployment strategy works very differently from a blue-green deployment strategy. Did it actually seem that different? Right? Like, was it really that different? Because you've got two environments in both cases. So then what was the major difference between A/B, which I also called canary, versus a blue-green, right? I would say that's false, actually. They are remarkably the same. So the only difference is whether you flip 100% of the traffic over to the new environment or whether you stick your toe in the water, which is what A/B is. A/B is you're like, I'm just gonna stick my toe in the water. I'm just gonna stick it in. Let's see how that goes, right? And then if you add in, seriously, if you add in linear into the equation, that's where you just step a certain set of traffic like every 5 minutes or every 10 minutes over. That's also just another variation on blue-green, another variation on canary A/B deployments. Okay, good job, by the way, participating. Let's talk about our scenario. Okay, so here we are. We're building an end-to-end application. And, here we are, and we have a user who's going to authenticate with Cognito. We're going to hit our website, and they're going to call our API gateway to do all kinds of CRUD. So you're going to be searching against notes / with actions like get. You're going to post with an ID. They're going to search with and retrieve information, and they're going to delete an ID, right? Fairly basic. Notice they have a question mark over in the lower right-hand side about a service that we have not talked about in any way, shape, or form called Amazon Polly. So I'm just going to let you know, Polly, Polly want a cracker. It's like a parrot, right? And so, yeah. So this service converts voice to text or text to voice. So anyway, this is what we're going to be doing for our scenario, is that we're going to add dictation into the equation, right? To get our notes. And then we're going to put some pre-signed URLs so that we can actually not have to force every user to authenticate every single time. And then we're going to have a Polly notes database in this case, right? The DynamoDB database. So this now leads us to lab 6, because all of this has kind of been pre-created for you. And there's certain pieces that we're going to add into the equation. So we're going to be developing an end-to-end application with this focus. Now, this lab has been allocated for 2 hours, right? And the reason for that, because it might may take less than that, is to make sure that you are slow, methodical, and meticulous about how you approach this, right? Making sure that regions don't switch, making sure you're following the instructions and directions, and giving you time to do the tiny bits of code that are actually there. But a lot of this is going to revolve around your orchestration of API gateway. And let me just tell you, just relax your eyes, chill, right? And just know that it's going to say like, you know, click here and then click here to test. And you've never seen this interface before. So just relax for a second. Take a second look. If you get really, really stuck, ask. You know what I mean? But like, just relax if you decide to take a run at this, right? Okay. So let's roll over. So we got 24 labs pre-warmed and ready. I don't know why I didn't do the full 25, but there's 24. I think there's 23 of you actually. So perfect. Whoa. Okay. So you're going to go ahead and hit start on your lab. But if we open the lab, right, what should be happening is that you're going to do the same thing about connecting to your thing, popping into your language. Notice there's a lot more options here, but let's say we're going down to Python. And so the first thing you're going to do is you're going to create an Amazon Cognito user pool. Manage the pool, create a pool. Hi, excuse me, I just got attacked by a dog who just licked my legs. And then from there, you're going to create a user for the Amazon Cognito user pool, right? And then you're going to create a DynamoDB table, which is going to be tons of fun. You're going to create a table, add some values, create a couple of S3 buckets, right? Notice it says polynotes, like first name, last name. It always surprises me what's not taken, by the way. Like John Smith will be able to grab a bucket. It's really weird, right? And then you're going to create the MP3 bucket, and then review an IAM managed policy, and then create the role, right, with the associated policy attached, right? And then create the role in question, and then you're going to create the Lambda list function, and then code the list function, which of course you've got like solutions code for that, which is, by the way, embedded in the directions. Create your polynotes list function in Lambda, test the polynotes list function, and then you're going to create the API gateway. And this is where people kind of get hung up. Just be patient with yourself, slow down, take a look at the interface, look at what they're asking you, right? And then create the Amazon Cognito authorizer, right, for the API gateway. Then create various resources for your API, creating the get method. You're going to create like, you know, a bunch of different pieces. Then you're going to create the front end website, which in this case, there's going to be like a main bundle.js file. You're going to create the whole thing, unblock public access. You're going to do all this stuff, and then you're going to test the web application. You're going to see this polynotes login option, which is going to be tons of fun. They're going to go back, and you're going to create the remaining Lambda functions, and then like hook them in, right, to API gateway. So you're going to create the remaining functions, and you're just going to keep going. Create the Lambda search function, create the Lambda delete function, and you're going to hook all that and create the remaining like portions of the RESTful API into the API gateway. So you're going to like fill out the rest of this architecture. And then basically at this point, once it's all tested, you're just going to go back and test your web application. There is a list of additional troubleshooting tips that can be found here, but basically know that, especially if you're conversant in code, you're going to take a run at this, you're going to write your functions, you're going to run through this whole thing. It's going to be an amazing experience, even if you fail at it. Just so you know, like usually about 75% of the class gets pretty close to completion. Not everybody finishes it, but usually at second or third run, people will complete the class, the lab. So just so you're aware, okay? So let's do that. Any questions at all about anything that we've covered in the last hour or so before we dive into this lab? Cool. Okay, let's get it. So it's 1:44 right now. I'm not going anywhere. I probably will step away in about an hour plus or minus 15 minutes, but I'll be back after about 10 minutes. I just need to get my kids all settled in. And then we're going to focus on lab 6. So we're basically doing this until pretty close to 4 o'clock. So let's get it. Let me know if you have any questions. As we're constrained. Okay. Let's see. A couple things that I was researching on. Hopefully you heard our conversation earlier about how lab 6, apparent, at least for me, I don't know that that's the global fix, but apparently if test user note 001 is deleted, at least it stops all session retention. Not exactly sure what that is. Let's see, a couple questions that maybe were asked and maybe hadn't been answered is that, can you add a nested JSON data item to a DynamoDB table? The answer is yes. Do note that that will cause issues with app sync and some of the TTL stuff. So make sure you read the documentation on that. Other question that was asked was, do you, if you submit time inside of DynamoDB, does it need to be ISO 8601 like compliant? It doesn't have to be. You can submit it as a string or as like a numerical epoch value or epic value. Sorry, epoch, epic value. Just know that if you do a string, it won't, time to lives won't work, but if you do epic, it will. Let's see, other questions I had here. Nested JSON. Oh, SAM local testing. So the SAM CLI will actually support local testing and deploy a API gateway locally. I don't really have a whole list of other tools since I don't do a whole lot of that, but I do know that the SAM CLI will support that. I can't remember who asked that, but someone did. And then there was a global indexes question, and I wrote down the worst notes for that in the entire world because it literally just says global indexes P. So I don't know if someone had an unanswered DynamoDB global indexes question, but I'm open floor to hear it right now because I apparently just wrote the worst notes ever on that particular question. No? Okay. All right. Hopefully that answers any pending questions. I think that was all of them. Anybody have anything else? Any open for anything that we haven't covered or talked about before I go through the closing of the class? Okay. Let's see. Let me close this out. Let's go through the official thing, and then I will go through my thing. All right. So let me share my screen. All right. So, by the way, we just spent 3 days, including that lovely lab that we just did, going through a like wealth of information related to AWS. I hope that you felt like you got fully immersed in the AWS ecosystem. Know that obviously there's caveats for everything. This is gotchas. But this is now 15 years old. It is the de facto way in which everybody deploys infrastructure now who is not running an existing on-premise company. So, and obviously it's not perfect as we've seen, but it is pretty awesome for moving things forward. So our focus is primarily on other things related to like typically what a developer will be looking at from a development function, everything from permissions with IAM to just general storage with S3 to storing database, to storing persistent data to using Lambda, because as we mentioned before, using virtual machines and containers in particular is probably like neck and neck with serverless, but virtual machines are slowly falling out of favor, which doesn't mean they're going away, right? You still need virtual machines to run containers, but has a kind of a base container or base platform for deploying an app. It seems to be diminishing greatly. Then SQS and SNS, along with step functions and Lambda, to kind of talk about some like loose coupling and some pub sub fan out models, Elasticache as well. And then we talked about some security options just in terms of certificate management, secrets management, that kind of thing. So then where do you go from here, right? That's really kind of the next step. One, it would probably behoove you to sign up for, if you are going to be in the AWS ecosystem where you've got a project, go sign up on AWS's blog for something. Like, trying to think of something like really specific, but the AWS blog is pretty robust. And if there's something that you are interested in, when you sign up for the AWS blog, you actually get a chance to actually sign up or choose like your particular formats. And you can sign up for specific blogs if you want to. The other thing is that there's some really great third parties out there, like Corey Quinn does Last Week in AWS. Not only is he snarky, which is kind of entertaining, but he actually tends to provide news that actually is meaningful. He also has a podcast. So his podcast, by the way, is like 15 or 20 minutes. It's super short. It's 3 days a week, and he just summarizes news and perspectives and other things that are going on in AWS. So he's a good one. Cloudonauts is another one. There's a bunch actually, but Corey is the unofficial marketing director for AWS. So he probably by far is the best one I've seen in years, actually, in terms of keeping information up to date. Obviously, if you use Feedly or some other kind of RSS reader, those are all super useful as well, just in terms of aggregating content that you're very specifically interested in off the web. Other things to note is that this class is typically associated with, typically associated with a developer certification, which is the blue hexagon, developer associates in particular. Notice that there is no developer pro because, well, there's a DevOps professional, which aggregates those two things together. So one thing to be mindful of is that this class is commonly associated, but it is not the only thing that you would do in order to pass the associate certification. To pass the associate certification, just to show you this, is AWS actually has some ramp up guides that they publish that some of the AIs like myself have actually contributed to. This allows you to choose it by role or by technology. So if you're looking at to get more conversant, more robust on some aspect of cloud, like maybe like containers versus cost management, or you have a role and you just want to like go take the exam, one of the things you can do is you can see, as I actually just downloaded the ramp up developer guide, and you probably don't need the fundamentals. You might even not even need like some of this other stuff that's actually in step 2, but you might, it just depends, right? But then you can learn all about containers, learn about the Elastic Container Service, learn about Kubernetes Service, learn about serverless fundamentals, and then learn a little bit about getting started with DevOps on AWS, and then maybe a little about some of the full stack stuff like Amplify, which is very useful. And then just so you know, even before you get to Amplify, you actually have the option to actually take this particular exam. So what I would do is that everything before step 6, I would actually maybe like at least kick the tires on a little bit. This is a great guide. It'll probably take you about 6 weeks at 5 hours a week to really prepare for this. If you want to go faster, put in more hours, right? But this ramp up guide is actually fairly decent at getting you ready to take the exam. There's one more piece that you need. And by the way, you don't have to remember all this. Not only is it being recorded, but I'm going to send you an email with all these links on it. So you're just going to have them instantly. Give me like a day or two. Things are busy. The other thing to note is that in addition to that ramp up guide that I'm going to send you, and by the way, I'm going to send you a link to all of the ramp up guides, not just the developer one. So you can just choose the developer one if that's what you're going after. The other thing is that there's a site called Tutorials Dojo out there. And Tutorials Dojo is actually run by a gentleman named John Bonso, and he makes some of the best, like legitimate, like, like test exam questions out there that I've ever seen. He's on Udemy as well. He does actually work with AWS to make sure he doesn't cross the line, which I think is actually pretty cool of him. But like to say this, one of the great things about John's exams is that he has a photographic memory. And so when you get his exams, you get a rewritten question that not only doesn't cross the line from a legality standpoint, but is actually really good against what's happening inside of the actual test. So if we go look at like his developer associates practice exam, am I not already starting the course? Anyway, what can happen here is that you can actually click into the exam, and when you run through these questions, if you decide to do 1 or 2 of the review mode set, he will actually prepare you to take the exam. And when you get like run through the question, he will not only tell you what you got right, but he'll tell you what you got wrong in it as well, right? I'm just gonna click one because I just burned my brain down trying to do all that troubleshooting. So just happened to be the right one. So he's going to give you the correct answer if it's correct, and then he's going to tell you why the other answers are wrong. He's going to give you the source documentation for where he got the answer from. And if he has a cheat sheet, he's going to give you that as well, right? So if you keep getting S3 questions wrong, just go study the cheat sheet. So Tutorials Dojo, again, this is all going to go in the email that you're going to get within 48 hours or less. Tutorials Dojo is one of the best practice exams if you decide to go take the actual exam itself. Now, the actual exam is $150. If you take it, it's a 65 question, 90-minute multiple choice exam. Is that 90 minutes? Might be 165, but 165 minutes. But it's 65 multiple choice questions, right? So it's very much, or at least at present, a trivia exam. You're not going to have to like do any coding. If you take some of the other exams, they do require hands-on, right? So between taking 2 of these review mode sets from his practice exam and then doing the previously aforementioned like ramp up guide, you are going to be better set than most people to really understand and use the AWS ecosystem. And just so we're clear, some of the stuff that's in this ramp up guide is actually their workshops. So you're going to put your hands on the console in your own personal account, and you'll probably spend $1 or less actually to run these workshops. And they are totally worth it. Especially in the frustrating kind of like troubleshooting, where did you go wrong aspect, it really teaches you a lot. Okay. So I'll make sure that you have the ramp up guide. I'll make sure you have access to like Tutorials Dojo, like you know where it's at. And I'll make sure that you have a link to the certification pages. Here's the other thing that I really enjoy sharing with people is I'm going to share a couple of URLs on a couple of free workshops. Let's see. Let's look, because I was looking up Nest.json. So if you look ECSworkshop.com, Amazon has a bunch of free unlisted workshops about how to use some of these services, right? EKS Workshop is another one, right? Where you can actually kick the tires on a whole. And by the way, this workshop is so unbelievably robust. It's just absolutely, it's awesome. CDKworkshop.com is another workshop. A lot of these, by the way, can be found on AWS Workshop, the AWS Workshop site. So there is a workshops.aws. And so what they've tried to do is start aggregating all of these unlisted workshops out here. And as you can see, this is done by subject. So if you need to know a little bit more about, I don't know, ML, right? It'll list all of the immersion days and workshops they have. And there's a lot more here. Like if you need to like dive into databases, guess what? RDS for Oracle, QLDB, which is the ledger database. Most people won't touch that. Postgres monitoring workshop. There's really great workshops here. Most of these will use your personal account, and they're going to cost you far less than $1 as long as you don't walk away in the middle of anything. So I'll make sure that you have this link as well. This has a lot of the workshops that I was just looking at. So want to make sure that you have this, especially if you're working on projects like modernization or migration. There's modernization and migration workshops in here. Tons of integration, tons of Lambda stuff, tons of API gateway stuff. Most of it's very code centric. So really great items here. So I'll make sure that you have all this as well in the email, so you can just quick reference it and keep it in your back pocket. There obviously are more trainings, and there's just one other site that I just want to make sure that you're aware of. That's aws.training. So if you haven't signed up for this awesome little addition to, and you can use your Amazon account if you want to, but if you haven't signed up for this site, aws.training, which again, I'll put in your email, this actually gives you access to a bunch of free content. And let me show you what I'm talking about. Let's say you wanted to kick the tires more on Lambda, right? Well, if you type in Lambda in here, it's going to give you all of the free like e-learning and video classes. And actually, I'm going to switch to digital training that you can see. So if you want to learn about Lambda at Edge, it's here. If you want to build a conversational dynamic bot, here you go, right? So some of these are e-learnings, some of them are hands-on workshops, some of them are videos. So if there's a topic, if you go to aws.training and you say, look, man, we kicked the tires on API Gateway, and that was just something I just need to know more about, right? Go up here and type in API Gateway, make sure it says digital training and not classroom training, and it's going to get you connected to a bunch of e-learning modules. Like this one's 3 hours, it's intermediate. If we go in here and start it, really? I actually started that? That's weird. Anyway, what will happen is it pops up in what is actually a pretty useful dynamic format. Left-hand side will actually have all the items on it. And as you scroll through, it will actually mark your progress, as you can see over on the left-hand side, right? So, you know, just to say this is that these classes are spectacular. So, you know, as you know, in the IT industry, all the information is getting smaller and our tool choices are getting really tiny and things are getting easier for us and there's less and less work being asked of us and we get paid more and more. I hope you heard the sarcasm and all that. So just know that like keeping up with skills and all this is unfortunately kind of like a requirement now. So I hope that you can add that to your toolkit as well, along with the workshops link, along with the digital guides on particular technologies. And, you know, just take it one piece at a time, stay focused. And the next thing you know, after the end of the year, you've got 2 new skills under your belt and you're ready to go. Okay. So at this point, I'm going to go ahead and officially close class out and end it a little early. And the main reason is that you guys do have your own internal like evaluation links. So I wanted to make sure that you had some class time at the end to work on it. But that's literally the end of the class. There's really nothing else here to cover, you know, other than just awesome training courses. You know, again, as it speaks to you, come do them, right? My contact information is michael.forrester@webhsolutions.com. So I'm actually going to post that in the chat so you can have it, but you'll also get an email from me for in a day or two. Otherwise, that's it. We're done. Finite, official close of class. We already talked about certifications. You already know your training URL. We're done. So thank you for hanging out with me for 3 days. It was spectacular. Sorry for some of the hiccups that we run into, but you know, that's also computing as well. So just let me know if you need anything. I'm going to hang out here for a few more minutes. Otherwise, thank you again, and we'll see you at the next class. Good. Yeah. Thank you. Thank you. Thank you. Thank you. Oh, also, I'll send the video link. So you're going to get the video of the class as well, unlisted just for you. So thank you for the feedback.